Thank you very much for your patience, wonderful support, enthusiasm for this program. So we are starting with our agenda. We have total 5 chapters in today's agenda. We'll start with the introduction to Hazop. That will be part 1 and part 2, definitions, Hazop concepts, Hazop methodology, and practical problem. So before starting the session, I humbly request you, if you are in the conference room or in public place, so please ensure the emergency preparedness for yourself. That includes the basic information about your facility, siren type, evacuation route, assembly points. And just check that whether if you are in the company or in conference room, so is there any mock drill today? This is very important, as we know that most of the fatalities are because of the improper evacuation. So this information is very much required whenever we are in the public place or we are in the conference room attending some lectures or meetings. Thank you very much. Now we start with the introduction. So regarding the Hazop, first question comes, why Hazop is required? What is the significance? Why we should do the Hazop? So basically you must have seen that either we have the new projects or during the operation also we make some changes. So how changes affects if we do not do the proper risk assessment? This is one of the classical video of one of the previous incidents. So please watch it carefully. Then we'll discuss it why Hazop is required, and you'll be able to understand why Hazop is required. Okay. Yeah. Okay. So this is regarding the one of the refinery. They have two arrangements of feeding in the where high pressure propane liquid was fed, but because of some changes in the process, company stopped one feeding and continued with the another feeding only. So because of this, that end, there was accumulation of liquid propane, liquefied propane in the dead end. And because of there was a change in the atmospheric temperature, low temperature during the night and high temperature during the day, because of contraction and expansion, there was a crack in the piping. And because of this crack in the metal, there was a release of the liquefied propane in the atmosphere. Because of this release, this reached to the boiler area where got the ignition energy and fire started from that particular area and expanded in complete facility. So we started with the jet fire. first, now second jet fire. This fire extended to nearby piping, resulting in the collapsing of the piping. So again, flammable material started releasing from the collapsing piping, and such expanded completely in the refinery. Fortunately, there was a evacuation system available, so they saved almost all the lives. After the 50 minutes, total evacuation was done, so saved all the lives. That was the better part, but total refinery was damaged, affected because of this fire. So from this wonderful case study, we can understand that either we go for a new project or we have any changes in during our operation. So because of this change, what are the risks associated? We have to identify it. And for process, that is the best practice is Hazop study. So that is why Hazop is required to identify the hidden hazard during the new projects or during the changes in the existing process. So basically, what is the process safety management? So process safety management requires business to properly manage hazardous chemicals with the goal of creating safe workplace and preventing unexpected release of toxic, reactive or flammable liquid and gases that can cause disaster. So basic aim to achieve through process safety management is we have to see that any release is prevented and any major disaster or minor disaster can be prevented by using different elements which are given in the process safety management. So that is a basic objective of the process safety management. So ultimately, we can say we have to save human beings, save our property, save the environment, and save the asset damage. So that is the basic objective of the process safety management. A systematic approach, we can achieve these activities. So when we see the history of process safety management, so when it was initiated or how it was developed. So we start with the 1985. Basically, there were many major accidents before the 1985 also, but the Bhopal incident triggered the requirement of process safety management. So in 1985, after the Bhopal disaster, CCPS was established by the US. The CCPS, we know that it's a leading organization in promoting and building the culture of the process safety management. So in 1988, CCPS published the Chemical Process Safety Management, a challenge to commitment. This was mainly for the top management, how just a vision and some guidelines how we should proceed. This was intended to educate chief executives about the importance of implementing the process safety management. So 1988 is a beginning. Basically, it's a top-bottom approach. So first, chief executives are given the guidelines and trained and aware them about the importance of the implementing process safety management activities. So PSM is a result of significant process industry incident. For example, as we discussed that 1984 Bhopal, then 1985 Institute, West Virginia chemical plant incident, evacuation of local communities, but no fatality. 1989 Pasadena, Texas chemical plant explosion, 24 deaths and over 100 confined injuries. 1989, the CCPS published important characteristics of our management system guideline for technical management of chemical process safety. So this was a guideline how we should start initiating the complete risk assessment procedure, risk management procedure. Those guidelines were first generic set of principles for use in designing and evaluating process safety management system. So the generic principle. At this stage, you will find a lot of different guidelines, but that was just generic. What is the broad? We can say macro level guidelines for the process safety management system. Then slowly, there were a lot of upgradations, new guidelines. So now we can work on micro level, but that was the beginning 1989 and the macro level. OSHA published the Process Safety Management Standard in 1992 in response to the several catastrophic chemical release incidents that occurred worldwide. So basically, if you have understood the complete process safety management system of whole globe, so we find normally two different guidelines. One is OSHA based on the US Labor Department. Second, HSE based on the UK. So European and American guidelines. So normally we say like that. We may find either OSHA guidelines or HSE UK guidelines when you refer any company's PSM guidelines. So in OSHA, we have 14, around 14 elements. In HSE UK, it's 30, around 30 elements. So everything is almost same, but division maybe 14 or maybe 13. Now, regarding the process safety management, CCP, a Center of Chemical Process Safety, that is a full name, in 2007 published PSM Safety Framework Guidelines for Risk-Based Process Safety. So real risk management starts from 2007. Before that, it was just broader guidelines we had. And if you recall or if you refer the earlier history also, before 1984, ICI was doing some risk assessment or Hazop study, but that was not in the present structure, but similar to that. Things were started before that also. 1984 Bhopal triggered that, then establishment of CCPS in 85, and then broader guideline, then slowly the deep level of the guidelines. So risk-based process safety approach is built on the 4 pillars. Commit to process safety, understand hazards and risk, manage risk, learn from the experience. So commit to process safety means it's the involvement of top executives, top managements and executives, making policies, guidelines, providing the funds. Understand hazards and risk means our risk assessment procedures or tools which we are using like Hazop, we do LOPA, we do SEAL, we do QRS, all these tools. Managing risk means actual implementation of all the findings and recommendations and maintain and monitor that thing. That is the managing the risk. Learn from the experience means mainly experience like we have say we have any incidents, so learning from that, lesson learned from the incidents. We have near miss, we have major accidents, so learning from that experience. Within our industry, within our group companies, maybe within the same companies, or maybe throughout the globe in different organizations, different sectors. So this is how a complete management process continues in the 4 step. Right. So now, what are the legal requirements for the Hazop study, and what are the basic references? So normally I will start with the Indian standards, and of course I will give the light on the international standards also. So the legal requirement, as I discussed earlier, that OSHA Process Safety Management Standard by the US Labor Department, that is 29 CFR 1910.119. And EAP RMP rule, that is 14 CFR Part 68, that is also the same department, Labor Department. And COMA regulations, control of major accident hazards regulations. Then IEC guidelines 61511 and 61508, that is for the Hazop study also. Normally, all over the world, we follow this guideline 61508 for the Hazop study. Then for India, of course, 1989, there was rules were introduced, that is manufacturing, storage, and import of hazardous chemical rule. That is an important rule for managing the hazardous chemical, handling the hazardous chemical at the site. In India, key law guidelines include the Factory Act 1948, Environment Protection Act, which also covers the risk assessment, that is in the process, in the storage also. So through the EPA, we ensure in India that new projects, they do the risk assessment and implement the recommendation. Then OSD guidelines mainly for the oil sectors in the India. PHSER requirement for the installations mainly, and installations, their manufacturing, their maintenance, their inspection, everything is available in the PHSER requirement. Now the references, the important references for the Hazop study. First is ISA 61882 2016, that is Hazop application guide. Then CCPS AICHA, that is Engineering Design and Hazard Evaluation Guide. So we will refer all these references throughout today's discussion, and you can refer in your Hazop studies also in the later on. And Chemical Industries Association 1979 Hazop Guide, that is original by ICICI, what I discussed earlier also. So ICI started in 1979 doing the Hazop study, but at that time it was not named as a Hazop study, but it was a process risk assessment. So they started it, slowly improved it, and at par at the present structure. So we can say ICI is a leader in Hazop study, structured Hazop study, but not in present way structured Hazop study. But at that time, it was a more structured, depending upon their situation in 1979 or 1980s. And ICHE, that is Hazop Safety Guide and Training Materials. Company-specific safety and risk management standards are, of course, available. And there are more guidelines are available. These are the global accepted guidelines, but you can refer as per your country's guideline also, or your state guidelines also. So these are the basic legal requirement references for the Hazop studies. I will share this presentation after the end of the presentation in this our HSE Process Safety Academy WhatsApp community and through mail also. So you can use in your future reference also. If you have any questions, please write down, keep a note. You can send us through mail also, because if time permits, we will give the response. Otherwise, we will make a video of this and we'll upload on our YouTube channel. So please keep on asking the questions. You can just write down, send through mail, or in the end of the session. Thank you. Please. Okay. Now, first chapter, part 1, we have completed. So now we are in the chapter 1, introduction, that is Hazop part 2. Now we will go in detail slowly. So considering the Indian scenario, appropriate stage for performing the Hazop. So as per Indian standard 15656, that is 2006, there are different life cycle of the stages are defined. So first is pre-design. So I will just parallelly refer the international guidelines also, practices for these stages. So basically, pre-design, normally recommended risk management practices are hazard indices, preliminary hazard analysis, what if analysis, or checklist. So in preliminary hazard analysis, basically this is the stage we can compare with the global guideline, that is a concept and selection stage. So here we just identify a few processes and we select from these processes. So in that case, we just concentrate on the major hazards in the industry, like storage flammable hazard, process risk like runaway reactions, or their uncontrolled conditions in case of overpressure and temperature. All this we can just discuss in majority of this case. Means we will not concentrate on the minor hazards, but major process hazards, major storage hazard, or major facility hazard. So that is a pre-design stage, or we can say concept or selection stage. Second is a design modification or design stage. So globally, normally we have seen that there are two stages in design also, that is basic design and detailed design. So for both this is applicable. So normally in this stage, we do process design checks and use with the use of checklist. That is initially, we do the HAZID study for mainly in international practices. In India, normally we very few corporate companies do the HAZID study, but internationally, of course, they do the HAZID study in these stages. Hazop study, failure modifier analysis as applicable, because FMEA is applicable to different part of the process, mainly for the where the possibility of failure in the equipment or system. What if analysis, if at all required, because what if there are not much hazards, otherwise we prefer the Hazop study. Faulty analysis, inventory analysis as applicable. But other than these studies, if you see a global scenario, so we require Hazop. After Hazop, we do the LOPA, we do the safety integrity level study, SEAL, that is classification, verification, validation. We do the QRA, we do the commerce studies. So all different, many tools are available that can be done based on the corporate guidelines. So second stage, third stage is the construction, that is applicable for Indian scenarios also and global scenario. So there also normally, as per Indian standard, it is not recommended to do the Hazop. But if you see globally, so we do the Hazop there also. Otherwise, we can, through checklist, what if analysis, manual or formatted BOPO, that is manual or formatted operations. All this we can use during the construction activity to identify the hazards. Commissioning. So commissioning stage, that is applicable in Indian scenario and global also. Again, as per Indian standard, Hazop and PSSR is not recommended, but risk assessment should be carried out, that is mentioned in the standard. So we can say PSSR is at least required for the Indian standards also. But if you see global standards, of course, Hazop, PSSR is the basic things. Uh, to start the commissioning, that is a pre-check, we can say. Pre-check is a PSSR. So as per Indian standard, it's a checklist, plant safety audits, what if analysis. So plant safety audit is almost equivalent to PSSR. So we can say it's a complementary of each other. So that is required in the both scenario, Indian and global scenario. Operation and maintenance, during operation and maintenance, of course, MOC is not mentioned in Indian standard or cyclic Hazop, but we see that risk assessments to be carried out, that is mentioned in the manufacturing, storage of and import of hazardous chemical rule 1989, that we should carry out the risk assessment at regular interval. So same we can apply here. So in both scenarios, if we say, considering these facts, that plant safety audits, of course, required. That includes the safety audits, PSM audits, or any other audits, relevant audits. What if analysis, depending upon the risk on changes in the process. Checklist, of course, if there is a no major hazard, it's a minor hazard is there. MOC, management of change, of course, this is required as per PSM 14 elements also, OSHA or HSE UK. So management of change, and we have seen in the video also that why Hazop is required, or we require the risk assessment in the process during the changes. So cyclic Hazop, of course, because we do small changes regularly to improve the efficiency of process, improve the quality, productivity, operability issues, to resolve the operative issues. So we do minor changes. So collection, if combined effect of that changes, we cannot. We don't do through the MOC. So cyclic Hazop address all these minor changes and see the combined effect of all the changes. So cyclic Hazop is required. That depends on the company policies. Some companies go for 3 years, 4 years, or 5 years. So that depends upon the company policies. But definitely we should do it. So here in the presentation, if you see all the red color shows that is the best practice for Hazop study requirement, however, not mentioned in the Indian standard. So that is a basic thing. Now, key points on Hazop from international guidelines. So again, we have seen that concept feasibility, identify the major hazards in the early stage recommended by HSC for early risk control. Design and engineering for both, I discussed earlier also that basic design and detail design. So same thing is construction, commissioning, operation, maintenance, and decommissioning. So in Indian standard, I think decommissioning is not mentioned. But if you see the global practice, so in decommissioning also we identify the risk, we identify the hazards, and we just ensure that risks are taken care before the decommissioning procedure starts. So these are the things normally applicable as per the legal requirements, standards, guidelines within India or throughout the globe. Now, fundamental of process safety. What are the basic fundamental of process safety? So we start with the framework to manage integrity of hazardous system and process. That is the basic requirement. The goal is prevent major accidents. Yeah. At this point, I would like to say this depend upon your company's progress on the implementation of process safety management. But any company when start the implementation of process safety management, their first goal is to prevent the major incidents, that is fire, mainly release of flammable and toxic chemical, which may lead to fire, explosion, toxic release, environmental harm. After achieving this, maintaining and sustaining, definitely we should go for medium risk also, then finally minor also. So it's an ongoing process. If companies start implementing process safety management, so addressing all the major accidents, I think they require 8 to 10 years. Then they can move to medium and minor also. But company team is very efficient, so definitely they can achieve in 5 to 6 years also. But we should not be optimistic while implementing the process safety management. That is the basic thing. We should have a realistic goal and should ensure that all the team members are involved, they are trained, they understood the things, and progress goes on. Monitoring is important part in the implementation also. So differ from the occupational safety, this focuses on large scale hazards, not minor injuries. So occupational safety normally it's related to near miss exposure, minor exposure, but here this concept basically for the large scale hazards. Now key principle. What are the key principle in the process safety? Normally, we prefer the inner safer design. So, inherent safety is a very important key principle, that is safe material and simpler design, user friendly design. That is the first principle. Second is hazard identification. So, as we discussed in the legal requirement also, in different stage of project, we do the hazard identification. So hazard identification normally start with the HAZID at the international level. In India, normally start with the Hazop and LOPA, sometimes checklist and what if analysis. So these are the basic requirement. Hazop and LOPA is not the end of the risk assessment in the process industries. We can say it's a beginning. Then we do seal, we do QRF for the storage, we do comma studies, different studies. So there may be more than 20 studies. So as applicable depending on the requirement, we do, but we should have the concept of hazard identification in our goals. That is the second principle. Then layer of protection. So layer of protection is very important because there are a lot of different requirement guidelines for defining the layer of protection. So that we have to follow. Alarms and shutdowns is a simple example, but basic concept is that your alarm should act before the event happens. That is the basic concept of layer of protection. Then operating discipline. Of course, operating discipline, we design system, foolproof system, but that is not communicated to the user, so it's useless. So training and SOPs. So training doesn't mean giving a classroom lecture, but a foolproof system like identification of training, continuous change in the plan every year of the training. After identification, your monitoring plan for training, pre-post evaluation, all this gives a perfect training system. So trainings and SOPs, that are the important part. SOP should also be self-explanatory, should have the good images for understanding, because we know that images we can understand very easily. It gives the clear cut idea about what we want to say. So if you use maximum images, that will help in implementing the SOP. And management of change, very important element, because any change in the process. So management of change basically not include up to the process also. It's a hardware, software, and our process. So basically we can say any change in process, in material, in manpower, that all requires the MOC. Manpower means not replacing the manpower, but we change the requirement of manpower, criteria, experience, we change the position from one to another department. All this requires the MOCs. Next is incident investigation and prevention. So basically, incident management system help us in reoccurring the same incident. So that is why lesson learned is important. Whenever we do the investigation, we should share the lesson learned. We should implement in all respective department and should train the people for the message from the lesson learned. So we have seen many circulations in this. Like Bitcoin is a very important. They share regularly all these things. Of course, CSB do the investigation, share the videos also. There is also the important organization working for the lesson learned training and awareness. Asset integrity and emergency preparedness. That is also one of the important, because asset integrity helps in damaging the equipment or asset and ultimately prevent the release. So that is also very important principle. Emergency preparedness, because in the beginning also I said that any emergency means a good evacuation system should be there, and we have seen the example that because of good evacuation system, refineries they could save the almost all their employees. So basically emergency preparedness is a very important part in case of any accidents. So these are the key principles. Now, process safety hazard analysis. What is PHA? Basically, this is important in identifying the risk, or we can say hazard identification and risk management. So, cornerstone of the process safety, that is, prevent fire, explosion, toxic release, catastrophic incident. has that is the cornerstone of process safety, preventing the fire. That is the main objective: fires, explosion, toxic, really catastrophic incidents. Hazards and diverse. Many techniques available. Choices depends on objectives and information. I said that hazard identification, risk assessment. Of course, many tools are available. Normally, in process, we start with the Hazop or sometimes checklist or what if analysis. So these are the hazards and diversities. Key techniques for identifying and managing the process hazard. That of course, hazard is the first step. As of what if, faulty analysis, inventory, botai we can say it's a beginning. Uh, After HAZID, we do the botai and then we do the comma study. We continue the comma study and with the MOPO sometimes. Then checklist, uh, IHA and LOPA. So these are the few PHR techniques which are applicable. Okay. So basically, just I would like to share one more information. That's a good news for you also. That this is just introductory Hazop, just to make everyone to bring everyone on one platform. But we will have a 40-hour Hazop session where we will have a deep dive and we'll discuss in detail about each and every part of the Hazop, references, practical examples also. So that we will share the timings and schedule of that later on, because every month we will have one training plus this is additional. Other than this training, we will have additional 40 hours, that is advanced PH and Hazop leader course. So you will find everything in detail in that course. So now we start with the definition. Actually, this first break is at 11:15. We will continue with the definition and we will do it. Uh, we'll take the break at 11:15. So we start with the definition. So which are the these are the few important definition which is required to understand the health of study. So first is the risk, which is the basic terminology. Combination of the probability of occurrence of harm and the severity of that harm. So what is risk? Suppose in general, just we come out of the industry and we say, we discuss about the our personal nature also. So in personal nature, of course, we have the behavior of anger. So anger, we know there are risks involved with the angers also. If we got angry, means we may end up with fighting with someone. We end up with the losing some our business also, or losing some important relationship also. So these are the, we can say, risk of our behavior anger. So combination of probability of occurring of the harm. Basically, behavior anger is a hazard, and because of this hazard, whatever we do, it's a combination is a risk. Whatever we lose is a combination is a risk. So combination of the probability of occurrence of the harm and the severity of that harm. Say basically, being angry means it's a, basically we can say it's our behavior, and loss because of anger, it's a severity. Like we can, it's a probability of losing the business, probability of losing the friends, uh, con- um, probability of being in conflict with the person or fighting with indulge in the fighting. So these are the severity, different severity of anger, and probability of being angry, that depend change from person to person. Some persons normally don't get angry. Some person frequently get angry. So probability based on that. So this is the basically risk related to our behavior angerness. The same thing is applicable in industry also. Simple thing, suppose we walk on the road within our facility or plant, so there are probability of vehicle movement and accident. So this accident, if we reduce it, maintain the speed 20 kilometer per hour, so maybe injury or body part damage. If we don't restrict the speed, so maybe fatality. So that is the severity and probability of happening the event. You can take the real life example of your industry, but may change from industry to industry, or you can have the thumb rule approach also. So basically, risk is a combination of severity and probability of harming. Harming to whom? So basically, consequence we take in four levels. One to human being, one to environment, one to asset, and one to reputation of the company. So globally, we follow four ultimate consequence. One is related to human, related to environment, related to asset, and related to reputation of the company. So risk is related to basically combination of probability of occurrence and harm of that and the severity of that harm basically. So we have the formula basically risk is multiplication of probability and severity in general. So deviation, that is a departure from the design intent. So what is basically design intent? Suppose we want to transfer a chemical from one tank to another. So we are using the centrifugal pump. So our design intent is we are transferring chemical, say petrol. We are transferring petrol for tank A to tank B by using the pump C, having the capacity of 10 meter cube per hour at ambient temperature and pressure. So that is a basically design intent. Deviation means departure from design intent. Suppose we are transferring 30,000 meter cube per hour of the flow. So it means our normal operating condition is 30 meter cube plus minus 10%. So suppose by any reason flow reduced to 20 meter cube per hour, so it's a deviation because our design intent is 30 meter cube per hour with 10% plus minus deviation. So that is acceptable range, but our flow is not 20 meter cube per hour, it's a deviation, it's a low flow. So basically deviation is departure from the design intent. Design intent is transferring petrol at 30 meter cube per hour of the flow from tank A to tank B by using the centrifugal pump C. It's a designer's desired or specified range of behavior for elements and characteristics. So ultimately designer's desired, but that is bounded by the requirement of the process. It's not totally design's desired because, but design's desired means here we can understand that basically he is following some basic guidelines, and based on that, what is the expectation from this particular process about flow of the petrol from tank A to tank B. So basically that is a design, just desired or specified range of behavior for elements and characteristics. So specified range of behavior means suppose we are maintaining the temperature in the distillation column 40 to 60 degree. That is a specified range of the element. Distillation column, we are maintaining a top temperature of the column that is 40 to 60 degree. And characteristics, so basically characteristic like we need the output from that column, this chemical A 80%, chemical B 20%, like that, or chemical B 10% and chemical C 10%. So that is a characteristic or basically behavior. Now, initiating event is the initial condition that triggers a chain of event leading to a potential hazard. Fine. Suppose we say we are hitting a column, starting heating at 60 degree, and we are taking the column bottom temperature up to 90 degree. So normal process is to maintain the temperature 90 degree, but because of some malfunction in the steam supply valves become stuck open. Or if it is a manual process, so by mistake, steam supply valve kept full open. So in that case, what happened? Temperature will start increasing. So this is the initiating event. Temperature will start increasing. Then there will be a escalation. So because of increasing the temperature, there may be increase in the pressure. There may be a pressure may reach a rupture or damage pressure of the equipment, will release. After releasing, then their availability of ignition source and converting into fire or explosion. So normally initiating event, we start with that event that is a change point, and whenever we do Hazop, we have to keep in mind that in case of consequence, we have to start writing from the initial event up to the ultimate consequence. So ultimate consequence can be again impact to human being, impact to environment, impact damage to asset, or reputation. Of course, impact on the reputation of the company. So basically, initiating event is the initial condition that trigger a chain of event leading to a potential hazard. Potential hazard means a fire, explosion, or anything in the fourth category: human, asset, environment, and reputation. Now, risk reduction factor. Fine. This is a very important terminology. Basically, there are two different approach we are using for the controls in the process. Or we can say safeguard and independence protection layer. So basically, risk reduction factor, when we consider the safeguard in the Hazop, normally we don't go for the risk reduction factor. We will just see the layers available, and accordingly we decide what the residual risk of that particular process or particular deviation. But when we go for the LOPA, so this is a very important requirement of risk reduction factor, because we have different controls. Like we are using shutdown system, we have the alarms, we have the SOP, we have the pressure safety valve, pressure relief valve. So basically, risk reduction factor or weightage of each control this protection layer have different weightages. Like for shutdown valve, we take a risk reduction factor 1 or 10. That is a 10 or single layer. We can consider a single layer. In case of pressure safety valve, if it follows the guideline given by the CCPS, there's a one table in the CCPS for the layer protection analysis. If we follow that guideline, so we can take 100 or we can consider 2 layers there. So basically, risk reduction factor is used in risk assessment to decrease the likelihood of an event occurring. So basically, how we decrease the likelihood? So we decrease by adding the more layer. So same fundamental concept that if shutdown system, so we'll consider 1 layer. If there is a PSV following the guidelines, clean services, so there will be 2 layers. So basically, in such way, we define the risk reduction factor. So finally, risk reduction factor is used in risk assessment to decrease the likelihood of event occurring. So when we'll see the deviation, we will identify the cause, we'll evaluate the consequence, then we will have protection layers. Then we will do the risk ranking, then with recommendation if applicable, and again risk ranking. So when during identifying the protection layers and giving the weightage, in Hazop normally one protection layer we consider for each controls. But in case of LOPA, we follow the CCPS guideline and table number for there. And we consider either 1, 2, or 3 layers. So like there is a different seal rating, seal 1, seal 2, seal 3. In case of seal 3, we consider RRF 10, 1000. So 3 layers we can consider in general. So these are the basic, this is the basic concept for the risk reduction factor. Now redundancy. Basically, redundancy involves I'm getting the different messages from the participant. Thank you for that. But sorry that we will not be able to address. But after the completion of the workshop, I will answer all these questions and we will prepare a video and we'll upload on the YouTube. So please note down your questions. We will make a series of the questions. We will share the sheet also, and you can refer. We'll share the time also for response of that question in the YouTube video, so you can refer that answers also. So please write down your questions. Definitely from chat box also we will note down. Our team is regularly noting down these questions, and then of course we will share the response. Because we have shortage of time, so sorry, but we will not be able to respond the time. But please continue to write down your questions, share in the chat box, or directly share in the official or WhatsApp community. Or directly share in the WhatsApp community also with your reference registration number. If registration number is not available, not to worry, just write down your name and question in the WhatsApp community. You can share here also in the Microsoft team also. So thank you very much once again for your active participation and questions and response. Thank you. So continuously I'm receiving the question. You can see on the screen that there are response and question. Thank you very much for that. Now coming back to redundancy, involves duplicating components or system to ensure safety and reliability. Yeah. So what is safety and what is reliability? Just let me explain it. Say there are two things. Basically, as I said, PSV, we use the PSV, and as per CCPS guideline, we can take 2 credits for PSV if it is for the cleaner service and comply the guidelines of CCPS. So basically, in that case, we will consider 2 control layers in the Hazop study. That is the safety part. But reliability, basically, what happens? Suppose we have a liquefied LPG storage tank. So there, as per legal requirement, we put one PSV, but because these tanks cannot, it's a continuous operation. Normally we use 24 hours running operations and 365 days. We take shutdown once in a year or once in a twice in a year. So in that case, what happens? One PSV comply the requirement of Hazop study, but as per our legal requirement, maybe country legal requirement or state legal requirements, we have to do the inspection and testing of that PSV. So in that case, we need another PSV so that if we remove one PSV, so second will be available. So that is why redundancy is sometimes required to maintain the reliability of the system. Of course, sometimes it's a process requirement also. So in that case, also we do the redundancies. Like as per few corporate guidelines, like Shell guidelines, we should have redundancy in our available control systems also, or power supply systems also. So battery backup is also required for the power backup. So these are the redundancies required as per the corporate guidelines. Also means we should have one standby system which can be used in case of failure or maintenance of the existing system. Like PSV, if we have two PSV on the liquefied petroleum gas tank, storage tank, and one can be taken for the inspection, testing, or maintenance. So similarly, in case of power failure, we need power backup to our DCS system because critical valves should be kept open or closed, so their redundancy is required. So this is basically based on the guidelines of company or process requirement or our inspection testing requirement. So safety integrated system, that is a SIS, basically automatically takes action to prevent accidents and minimum safe operation. Now we were discussing the safety. Yeah. Now we were discussing before the break that about the safety integrated system, that is automatically takes action to prevent accidents and maintain safe operation in industrial process. So automatically take action means in general we can say there is a sensor which sends it, which transmit it uh, from their logic solver, and logic solver will again give the command to the element. So this is a particular complete loop is there, and that loop functions and gives the automatic response to the abnormality in the process. So automatically that takes the action. Suppose we are maintaining the temperature of the distillation column, top temperature. And suppose the temperature, there is increase in the temperature. So temperature sensor will sense the temperature, give to the logic solver. Their logic solver gives the action again to the control valve, and control valve is slowly close. So this is basically how automatic action takes place. And of course, there is a response time. There is always a response time for different elements. Like we have alarm, we have a manual actions, or we have the automated system. Like we can say safety integrated system. So basically, global guideline is that normally we take the response time mainly for the QRA, but if anything is not available for Hazop also, we can take this as a guideline. We can consider this as a guideline while deciding the protection layer or safeguard or control. So basically, for automated systems, we normally take a response time of 2 minutes. For alarm, a response time of 10 minutes. If any manual intervention is required at the field, so its a response time is normally 30 minutes. Of course, you can calculate and identify your response time for individual automation or alarm or manual response. But otherwise not available, then we can use this as a thumb rule while deciding the control layer also. Layer of protection also, safeguard also, that for automated system 2 minutes, for alarm 10 minutes, and for manual intervention 30 minutes. So basically, if you recall in the beginning, I said that this control should act before event happens. So in that case, this response time is required to finalize a control which we are selecting or which we are mentioning for particular deviation is really applicable or not applicable. So this is a safety integrated system that is normally we call a SIS. So through this SIS, normally after the Hazop, we do the LOPA for the SIS and seal also. Now, admin barrier. So admin barriers are the procedural measures that help prevent accidents and manage risk. So basically, admin barriers are procedural procedures that help prevent accidents and manage it. So procedural procedures like as a standard operating procedure. Some company consider training also as a part of admin control, guidelines, rules. But basic concept when we select any safeguard, basically suppose we go for training. So training means it's a foolproof system. Like training need identification, then annual planner, then pre-post evaluation, maintaining records, and evaluation of the training system. So this is a foolproof system. Similarly, if we say standard operating procedure, and we consider layer of protection or safeguard, so it means we consider that SOP, standard operating procedure, is properly implemented, training is given, and refreshing trainings are continued as per the requirement. So while choosing the admin barrier, we have to be very specific. We cannot say that SOP is available even it's just documented, not given the training, not properly implemented. Otherwise, our risk assessment will be inadequate. So please consider while select. Please be specific while selecting the admin barrier. Now, probability of failure on demand. So we can say it's a reverse of the RRF, risk reduction factor. So basically, it represents the likelihood that the system will fail to perform its intended safety function when demanded. So basically, say for the example, if we say risk reduction factor is 10, means we say the probability of failure or demand is 1 into 10 years. For any, say normally, if you see the CCPS book for the layer of protection analysis, table is given. I just forgot it's a 7 or 10 number table. The table is given in that. Suppose we say it's a risk reduction factor for automated system. SAIL 1 is 10, means probability of failure and demand of that particular SAIS or automated system, that is once in a 10 year. Suppose we consider probability risk reduction factor is 100, so probability of failure and demand is 1 into 100 years. So similarly, basically, probability of failure of that particular element in duration in years, that we consider as a probability of failure on demand. Demand means suppose automated function, we require the temperature is increasing, and that temperature control should perform. It should detect this signal from the sensor, transfer to the logic solver. Then again, logic solver will give the command to the control valve. We want this function to be continued. So that is a basic requirement of that design function, design intention of that particular control valve, and a particular that safety integrated system or SEAS of that automated control valve. So in that case, say any design basically subject to the failure. So that we have to know what is the failure on demand. So when the temperature control is required to function, so what is the failure on demand of the temperature controller? As per CCPS, it's a once into 10 years, once in 10 years. Similarly, PSV failure on demand probability is a once in 100 years. So likewise, we have the standard data references in the CCPS that we have to follow, or we can say it's a reverse of the risk reduction factor. So that is the basic difference between RRF and PFD. Now going to next slide. So now we have completed the second chapter. Now we are entering into chapter 3, that is the Hazop concept. Up until now, we were just understanding basic things related to Hazop study. Now we will go slightly deeper in the Hazop, that is the Hazop concept. So Hazop means hazard and operability study. So basically, if you see, we do risk assessment or risk analysis. Okay, let me explain here what is analysis and what is assessment. Basically, what happens, suppose say we did the schooling and colleges also, we were giving the exam. So let us take that example. So there is a question paper, we give the answer, we don't get the marks, so it's analysis only. When we compare this, we get this our score, that is suppose we score 90 out of 100. So it's a comparison. Out of 100, we get the 90. So it's assessment. That is a basic difference. If we write down the answer, but we don't get the marks, so it's analysis only. So similarly, in the case of Hazop, suppose we do the Hazop study or any risk assessment, we are using any risk assessment tool or any HSE studies. So we have a deviation, then we have cause, then we have consequence, and then we have safeguard or layer of protection. after we do the risk ranking. Okay, ideally, let me say, normally, ideally, risk ranking should be done in 3 stages. That is, first is the potential risk. That is, uh, after deviation, we have a cause, consequence, and then we should the risk ranking. It is called a potential risk. Then we have the safeguards or layer of protection. Then we do the initial risk ranking. Then we have recommendation if required, if our existing system is not in allowed. So we have the safeguards, we have the recommendation, and then we again do the risk ranking. So basically, if we do risk ranking in 2 level or 3 levels, so it's assessment. What was initial and then what is now residual risk. But we do risk ranking only for the one stage, that is after the layer of protection safeguard. We do the risk ranking, and if we feel we give the recommendation, but we don't give the risk ranking, we don't do the risk ranking, means it's only analysis. So only one ranking or one quantification means analysis. Comparison means as a ranking assessment. So assessment is we are comparing two different situations. So that is the basic difference between risk ranking and risk assessment, right? So now, basically, when we do the risk assessment, so in our facilities, normally we do HIRA, Hazop, and JSA. It's a general thing. So let us see what are the basic difference between HIRA, Hazop, and JSA as per understanding. I just want to add here that few companies may have different guidelines for Hazop and HIRA. You may find what I share, that is some difference in your company guideline or whatever you have read or you had a reference. But for understanding, let us have this explanation. So acceptance, first aspect is full form. So HIRA, hazard identification and risk assessment. Hazop is hazard and operative study. JSA is a job safety analysis. What now focus on these studies. So first of all, HIRA, overall workplace process risk. So in general, we can say overall, other than process, whatever we do, or overall workplace, like we have fire hazard, we have toxic release hazard, so that we address in hazard. Otherwise, other than process related activities, like we are shifting the drum, we are handling the material, so that we can capture in the HIRA. Hazop purely for the process. So process deviation and design intent normally we address in the Hazop. And JS is a task level hazard. So normally, in general, as per understanding, we do it for the non-routine activities like your maintenance activities, one-time activities. Normally, we do the JSA, we attach with the work permit. That is a basic concept. But your company guideline may have a different opinion, so that you have to respect your company guidelines. Now, level. So, what is the level? So, basically, HIRA is a macro, it's a broad level. As I said in the beginning, that during the concept and selection, we do what if, checklist, all this, that is like a macro level study. So, like HIRA is also macro level study, while HAZOP, it's a detail, so we can say micro level risk assessment of the process. And again, JSA, micro level risk assessment of the job or activity, mainly non routine. But you can consider routine also if your company guidelines says that. Now, approach risk matrix based approach. In the HIRA HAZOP, we use the guide word, that is this your parameter and guide word basically, and combination of that. And JSA is step-by-step job analysis. Suppose we have one activity, a non-routine activity, like we have maintenance or excavation. So in excavation, what are the steps we have to follow? Like we just have to inspection the area. We have to identify the scope. Then we have to first dig up to 1 meter. What is your company guideline? So step by step, we have to mention the steps, and we do the job analysis or risk assessment for that particular steps. Similarly, team required. For HIRA, it's a small team, individuals. But of course, in HAZOP, we need a multidisciplinary, because in HIRA, it's related to facilities, so production team, maintenance, they can do it. But in HAZOP, we need like production, operation, process, maintenance, project, inspection team, your static and mobile team, or all the related teams should be available for the HAZOP. Then only we can do a best HAZOP. JSA mainly supervisor and workers related, so that team is required. They can do it because they work on shop floor, so they know what are the actual steps required for doing particular non-routine or routine activities. The documentation. So basically, HIRA normally we register, we maintain the record in the risk register, or we can say even from the HAZID also, whatever comes out, we maintain in the risk register. Also, we made the risk register separately for the projects also directly. So that is the risk register we maintain, that we can incorporate our findings of HIRA in the risk register. Hazop, it's a multidisciplinary team, and we use the software mainly for facilitation normally. But of course, without software also, in Excel also we can do it. But we maintain a systematic record in systematic manner. GSA, of course, same. GSA or GHA form. So Hazop worksheet is the main thing in the Hazop. GSA and GHA form in the GSA. Frequency, periodic as needed for the HIRA. Hazop normally, as I discussed that in the during the all stages, required stages of the project, then at the time of MOC, or cyclic Hazop every 2 year, 3 year, or 4 year, or 5 year as per the corporate guideline. GSA, of course, it's a routine, mainly non-routine activity, so it should be done before job execution. Say, for example, if you have same repetitive activity, so you can reuse same GSA, but you have to ensure that there is no change in the scope. So that is basically, that is why we attach the GSA form with the work permit also, and we give the toolbox talk to the participants also. So that is because it should be done before the job execution, all the non-routine activities. Mandatory under which guidelines? So HIRA, basically ISO 45001 or Factory Act. Hazop, OSHA, PSM, IEC, manufacturing storage of import of hazard chemical rule, all these are required. And JSA, mainly PTW, permit to work system. Main compliance is of GSA is for the permit to work. And second thing, if you just try to see your permit system, so basically we design the permit system based on the GSA also. Whatever checkpoints comes in the GSA, that we include in the permit system. So at the time of designing of the permit system also, we use the GSA techniques. So these are the significance of HIRA, Hazop, and GSA, and difference between amongst them. Now, what is the Hazop concept? Hazop study is a structured method used to assess the safety and operability of plant or existing process. So basically, it's a very structured system. We have the worksheet to record the Hazop notings. There is systematic guidelines. We have the list of the parameters which we can consider, and we can define the requirement of parameters in the beginning of the Hazop also. So it's a systematic approach. It's a qualitative, we can say semi-quantitative method, but a systematic structured method to identify the hidden hazard in the process. Now, success of Hazop depends on the three key factors. Assembling the right multidisciplinary team. So team formation is very critical in Hazop, because it's a brainstorming. Continuously, we need a feedback from the respective teams. So team formation is a very important factor in conducting the Hazop. Using accurate and complete information. So of course, data collection, second important key factor in the Hazop. Data collection should be perfect, should be properly maintained, documented, and scope is defined. Third is starting with a well-developed design. So that is a one more important factor in the Hazop. But there are a lot of other factors like defining the scope, terms of reference, finalizing the terms of reference, a system, proper planning of the workshop, location of the workshop, available aids for this Hazop workshops. All this makes the difference. But these are the three key factors. That is multidisciplinary team formation, complete information, and well-developed design. So that makes a difference in the Hazop study. Hazop applies guidewords to process parameter to uncover risks that may arise within design limits due to equipment aging, operational changes, or human error. It also reviews construction, commissioning, and operation practice to ensure compliance with engineering standards. Okay, at this time, just I would like to add that we have received the request that this should be done in the Hindi also. So we may develop our separate Hindi channel for our academy, and all whatever we will do the trainings, webinars in this particular English, we will try to make available in Hindi also. So these are the frequent requests to us in last few days. So again, coming back to the Hazop, because Hazop, few terms in Hindi, those who understand Hindi, they cannot understand in English. So that is why definitely we'll consider this request. Now, Coming back to Hazop, applies guidewords to the process parameter to uncover risks that may arise within the design limit due to the equipment aging, operational changes or human errors. It also reviews construction, commissioning, and operation practice to ensure compliance with the engineering standards. So basically, simply we say it's a normally in the early stage of Hazop, normally we are calling it as a parameter and guideword process. In 2007 or nearby times, later on, everyone accepted this as a Hazop methodology, but initially we were calling it as a parameter and guideword method also. So there we make a combination of parameter and guideword, and like with this combination we uh, define the deviation. So say for example we have flow, so we just make the combination of no flow and we define the deviations: more flow, less flow, reverse flow, misdirected flow. So all this combination we can make the combination and we see whether this is applicable for particular deviation or not. So basically Hazop we do with the help of the guide word and parameters. Timing is critical. Most effective when design is stable, typically when P&D is finalized and stable. Of course. So basic of Hazop is P&D. First basic thing, and P&D is a language for the chemical engineers. So we have to understand the P&Ds. We have the separate video of P&D also. We will share in the. It's there's no audio, but it's a simple presentation. So my team will share in the chat box today. So you will find you can refer that also. Of course, there is a standard reference book also. That reference book name is also mentioned in this presentation. But P&D is it's a very basic thing, as we know that to understand the uh, basic design of the chemical plant. So we can say it's a language of chemical engineers also. So P&ID should be the perfect, fully completed. Then only we should start the Hazop. And of course, deciding the quantum of the Hazop for numbers of day, we refer the P&IDs also. Just for your experience, just for knowledge, because normally per day it may be we complete 2 or maximum we can complete 5 to 6, that depending upon company's expectation. So I think in any case nothing is wrong if we do 2 in 2 days or in 6 days. But what should be our approach is that suppose we have started implementing the PSM. Of course we are not much aware about the Hazop, so we can complete in 6 days also because it's a beginning. But slowly we have to improve our Hazop process, and we should achieve the target that we should do only 2 P&ID per day. That is I can say it's ideal. But again, P&ID is quantum varies from company to company, from consultant to consultant. In some consultants, a P&ID drawing, you may find lot of equipment. In ideally, we see 1 to 2 equipment with auxiliaries. So that is the ideal thing. In that case, suppose we say if it's a critical thing, we should consider maximum 2 P&ID per day. One is also okay in that case. It's a medium, so we can say 2 to 3 P&ID. Maximum in the beginning, you can consider 5 to 6, because initially when you start things, a lot of factors are there. Your capability of team, financial resources of the management. So considering that, because we are doing something good, so we can start with the 6 P&ID per day, but later on we can improve it and reach up to the 1 to 3 P&ID based on criticality of the particular operation. So basically, this is the basic Hazop concept. The significance of the Hazop study. Through Hazop study, we can achieve the following: process hazard identification assessment. So we identify the hazard and we do the assessment of the complete deviation. So that is the first objective from the Hazop. That is process hazard identification assessment. Now, operability assessment, maintainability, startup, shutdown issues, if any. So basically, when we started the Hazop, we can say ICI started in 1979. Then in 2007, macro level guideline of CCPS, later on development. In initial period of development, normally we are concentrating only on the process. Slowly, it extended to the operability issues, extended to the startup, shutdown, emergency shutdown. We added other parameters. Say, if we do all applicable safety studies, then there is no need to expand the Hazop study. Like we need not to consider the emergency shutdown, startup shutdown, contaminations, corrosions, fire explosions in the Hazop study. But suppose we have started implementing the PSM system, or we are in the initial stage of the Hazop studies, like 2, 3 years, 4 years, 5 years. Until we do not start QRA and other tools for the risk assessment, we have only one tool, Hazop. Then we should try to consider few things like startup shutdown related issues in the Hazop, emergency shutdown, your corrosion related, mechanical failures, fire explosion, area classifications related few things. So at least we can address minimum things and we can improve our system. So that is the basic concept. So operativity, assessment, maintainability, startup, shutdown issues, if any. Okay. Now, third thing is preventing accidents. So that's the basic objective, of course. For any risk assessment, this is a basic objective to prevent the accidents. Regulatory compliance, of course, because of course regulatory compliance is also introduced to minimize the accidents. So to identify to identify the hidden hazards and do the risk assessment and comply the requirements. But few companies, if they are purely doing the regulatory compliance also in their units, so that is also a driving factor for them to do the HAZOP compulsion. So in some cases, like clients also keep the requirement that we should do the HAZOP study. So this is a out of thinking requirement. But of course, many of the companies in India, their HAZOP requirement is because their client force them to do it. So that is a regulatory requirement or client requirement, and cost effective, of course. Cost effective because ultimately, if we add anything to our process, like do we do risk assessment, so it will help us in reducing the accidents, so downtime, so increasing the productivity, increasing the profit. Of course, training one of the part of this element, PSM element, so that also improves the productivity. But say in India, if you see, there are different levels of companies there in the stage of implementing the PSM, process safety management, and that is a driving factor for, or we can say, motivation for us to start these free trainings also, and to start a postgraduate diploma in process safety management. That is a 4 to 500 hours of the course, and that will be affiliated course. So that we will share later on as on the progress goes on. So basically, of course, those who have started or in the process or already effectively implemented, they know the benefit of the Hazop study. Okay. Now Hazop concept. Basically, Hazop study, it's a basically steps, we can say, Hazop concept. So basically, we start with the, after collecting the data, actually this concept is after collecting the data. So we start with the node identification, design intention, defining the design intention, listing the parameters, guide words. We start with the deviation. That is a brainstorm session starts with the deviation. Normally what happens, if we say preparation, so there are two different approaches. Companies, they just collect the data and sit together in the workshop, and they start discussing the design intention, defining the parameters, guide words, listing out the deviations, or node marking also. And second approach is that we prepare everything in the backend up to the node marking, then we start brainstorming from the deviation. So in the second approach, we'll save almost 30 to 40% of the time. It is always advisable that we collect the data, circulate to all team members, we define the scope through the terms of reference or by any other means. Then we list out the nodes, share the nodes with the team, then we mark the node and then come in the workshop. So this will save 30 to 40% time of all other team members, because this preparation required scribes input only and chairmen or facilitators, and to some extent the process engineers or operation engineers. So other teams may not require their your presence in these cases. So we have to do the preparation, then should start with the this deviation in the workshop. That will save almost 30 to 40% time of the workshop. Okay. Now chapter 4. Now comes real input of the Hazop methodology, a real deep diving of the Hazop methodology. So we are starting with the chapter 4. This is the basic of the Hazop, we can say. So Hazop methodology. maybe different approach, different steps based on the company's guideline. But in general, we should start with the data collection. So data collection, we have a list of the data required. Uh, of course, basically PNDAD is a basic thing. Then PFD is required. Brief process description is required. Cause and effect is required, or interlock list is required. Then, of course, equipment specification. All these are minimum requirement for the documentation. Chemical properties, so MSDS is required, and I recommend you to prepare a table of summary of the MSDS so that quick review is available during the workshop whenever we required. So data collection is the first part. Then we do the project scope definition. So define the objective and extent of the Hazop study. So we have to define the objective, design intention, and boundaries or battery limits of the Hazop. Then it is advisable to prepare terms of reference which include the project scope, methodology, team, listing of the team, of name of the team members, who will be the chairman, who will be scribe, which reference we are going to use. In case of numbers of references, like as of guidelines, there are 2 or 3 guidelines are available. So we have to list out the order of precedence also in that terms of reference. And then we should send it to the approving authority. After approval, we should share this, of course, including the we should also include the terms of these parameters and guidelines which is to be used in the Hazop in the terms of reference. Any additional thing you can also add, your risk matrix also. So now then you have to send it to the approving authority. After approval, we should circulate to all the team members, so they come in the workshop with well prepared about this Hazop study, and their contribution or their documenters, they come with their documentations also. So basically, this is the project scope definition. Then in pre-preparation, what, as I said earlier, that this pre-preparation can save 30 to 40% time of the workshop. So of course, it's a saving means it's a huge saving, means like 30 to 40% timing of each participant, cost of the company, of course, and overall productivity of the company. So now in the pre-preparation, review all collected documentation in detail, understand the design intent of each system, just get the approval of terms of reference. Then the role of scribe is, that is to Hazop nodes. So define the Hazop nodes and get approval from the chairman and concerned process owner. Then parameter and guide word list that is required, which normally we circulate with the terms of reference. Then Hazop worksheet template, that also should be the part of terms of reference. What template we are going to use in the Hazop for the worksheet. So these are the initial preparation. Then identify potential complex or safety critical areas in the advance. Yeah, that will help, because we have to concentrate more on the safety critical areas. In general, we can say we have to concentrate more during the Hazop for the high severity or major accident related deviation. Our planning should be like that: maximum time in the major accidents related deviation, sometimes in medium, and very small time in low severity. That should be our objective, so that you give a proper justice to your Hazop workshop and study. Now, methodology, next step: client review and approval of the notes. So submit prepared note list with the boundaries to the client. Yeah. After the approval of terms of reference, we should prepare the node list and we should submit to the client or process owner, and with the boundaries of the client. Yeah. And incorporate client feedback and operational input, because when we submit, the client may give some comments, so that we have to incorporate the comments and we have to resubmit to client, so he or she can circulate in their team. Obtain formal approval of notes before the workshop to avoid scope creep, to ensure efficient workshop execution. So this is basic requirement, so that we have very peaceful, very smooth workshop. So this is the basic guideline for the smooth and peaceful workshop. That is just get the approval of everything and properly define scope and battery limits. In the 40 hours lecture, I will just share a few tips how to, mainly for the facilitator and chairman, how to make a healthy, peaceful, and joyful session. So that way I will share. So I recommend you to participate if you want your career to build in the as of leadership or as of chairman or facilitator. That workshop also will be free of charge every Saturday and Sunday, 2 hours. We will just check we will do the survey and check the timings of the workshop. But 4 hours in a week, 2 hours each on the Saturday and Sunday, so total 10 weeks. Okay. Hazop methodology. Now, Hazop workshop execution. So first thing is uh, select a node which contains an elementary unit of the plant. So we start with the node. Suppose we have 8 to 10 nodes, so we start with the one node. That is the first step of the process normally. So selection of node which contains an elementary unit of the plant. Then define the node design intent and process conditions. So we define normally in the worksheets also. In the practice, we will see today. If time permits, we will go in detail. That we will just describe the design intent into the streams, various streams. So we'll just list out the streams and we just define the design intent of complete that particular node. Then apply the first parameter to the nodes such as flow, pressure, temperature, level, composition, etc. So then we start with applying the first parameter, that is, now let us say flow. So we'll just start with the flow and we'll make the combination of flow with no. So no flow. So again, if you go back to our example, again, if you go back to our example, that transfer of petrol from tank A to tank B by pump C. So suppose we say no flow. Suppose we say no flow. So no flow means we can say no flow of petrol from tank A to tank C by pump, sorry, tank A to tank B by pump C. So that in that way, we just apply the parameters to the node using the flow this and make a combination with the guide word. Apply suitable guide words such as more, less, no. That is a combination. C and D is a complete one step. E is obtain a meaningful deviation by combining guide word and parameter. Example, more flow. So obtaining or writing a meaningful deviation means what happens? Sometimes people say no flow of petrol tank by this pump. So what happens at the time of Hazop, we all are in same mind frame and we know what is the meaning of this particular deviation. So you can understand very easily. But what happens? This Hazop report sometimes we have to refer later on for abnormality in process at the time of accident or incident, or we are using this for the training purpose also. So person who are referring later on, they should understand clearly what was the deviation considered. Suppose we say flow, so we can say no flow. In case of temperature, we can mention the temperature. Also, we can define the specific property also there in the deviation. So deviation should be foolproof and should be a self-explanatory in any case. If you don't see the drawing also, it should be self-explanatory to us. That is the basic intent of writing a full design, full deviation. So the writing deviation, cause, consequence in details, and best practice that I will again share in the 40 hours lecture. But just here understand that meaningful means should be self-explanatory. So in our case, our example, so we can say transfer of petrol from tank A to tank C, tank B by pump C. If there is any filter, so through the filter, so and so. So this is the basically meaningful deviation. Now, next is identify the potential and credible cause associated with the deviation by brainstorming. So, identification of cause now is a very important thing. So, here also we should write it properly. We say, suppose this transfer of petrol is not a regular activity. We transfer only when it is required on demand. So, there we can say when the transfer of petrol is demand, failure of shutdown wall or transfer wall in between is there. So that is we can that way we can just list out the causes. So causes should be also self-explanatory. If you say human error, so we just write down human error, inadvertent closure of the manual isolation valve in line from tank to pump in a section pump section line, or we can say in line in pump discharge line from pump C to tank B. So like that, we have to just write down the cause, that is human error. What is the human error? So it should be a self-explanatory. Whatever we consider during the failure of cause, that should be mentioned in the cause column. Otherwise, what happened during the workshop? No issue. You can understand and you can discuss it. But later on during the reference, they may not be able to understand what was actually considered. So really important. Suppose we consider a particular temperature also for the failure, so that also should be mentioned there. Likewise, we should mention everything in the cause also. Then assess the consequence of each cause. Just please refer my earlier discussion that starting from the initiating event, that in the definition of initiating event, I said that our consequence writing should start from the initiating event, and all the escalation like failure of malfunction and stuck close of steam supply valve or stuck open of steam supply valve lead to increase in the temperature, increase in the pressure, may reach up to so and burst pressure, release of the chemical, of course, and fire hazard. Of course, fire hazard, there are different probabilities. So we should consider major, medium based on the severity of that particular fire intensity. So basically, consequence. Then ultimate, we should write the ultimate consequence also in the consequence, right? What will be the impact on human being, or if any, or any impact on environment, impact on the asset or reputation. So, like in case of human, first aid or major body injury or fatality. In case of asset damage, we can say amount of, like say, we say because of non-availability sanction, there is a damage in the pump seal. So, what is the cost of the seal? That we have to just consider that. Then, in case of environmental damage, so what is the level of environmental damage within the plant, within the company, impacting the surrounding people? Evacuation is required to surrounding people, or like that. And reputation maybe as per the company guidelines that we have to mention there. We can mention all applicable. We can mention all applicable consequence, but in case suppose we have three consequences, it's impact on the human being, impact on the asset, impact on the environment. So we should write separately all the consequences. Should not write in same consequence all these things. So that is the ideal practice. Next one is identify safeguards included in the design to prevent and or mitigate the hazards. So of course we have to identify the safeguard, keeping in the mind as I discussed that risk reduction factor or probability of failure on demand. So what credit is applicable to particular that safeguard. So normally in Hazop, if you don't consider this PFD or RRF or numbers of layer for that credit of the layer, that is fine because Hazop doesn't say that all the Hazop methods, but because in India normally we start with the Hazop at that time, we do not do the LOPA seal and other uh, risk assessment methods or risk assessment tools we are using. Only Hazop. So I strongly recommend that understand the this layer of protection guideline and try to use independent protection layer concept, that is risk reduction factor credit 1, 2, 3. So that will help you in making a good Hazop report and of course reduce your risk of the plant to the minimum level. So I strongly recommend to use, if you have only Hazop in your company, you are not doing QRA, you're not doing LOPA, not doing SEAL, comma study, BOTI, and better you use independent protection layer concept. But anyway, beginning anything not done and you start doing the Hazop, that is a good and you can use anything. But slowly try to reach to the that level. That is my recommendation. Fine. Okay, now Hazop workshop execution. Agree a recommendation for action if the existing safeguards are found to be inadequate. If an immediate solution is available and acceptable to the team, the modification is recorded in Hazop worksheet and Hazop master P&ID will be marked up accordingly. Where solutions are unlikely to be derived without a technical evaluation, the chairman will refer the problem for separate assessment. Basically, uh, say, a chairman may have better knowledge. He is coming from the world of the best company. But when we do the Hazop, it's a practical experience what I'm sharing with you. When we do the Hazop, we have to evaluate in initial 2 3 hours by the response of the team what is their level, and our objective as a chairman or leader should be or has been that we have to improve at least 10 to 50% or 20% in the our company's Hazop system with particular Hazop. So as a chairman or leader, uh, we should consider that whatever we recommend, that should be acceptable to team. Why I'm asking this? Because there are reasons. Suppose we feel that it is required, so but company side during the implementation, there may be the team, if they don't accept, they will not implement it. So any recommendation if we give but they don't implement, so there is of no use. So instead of that, we should give the feasible implementation recommendation, feasible recommendation, so that they can implement it and slowly they can improve their safety system. So we cannot achieve directly 100% from the zero. So our goal is, suppose company is in 30%, so we have to move it to we have to take them to the 40% through this setup. Likewise, if we will do it, so team will be also be happy, management will also be happy, and they will improve their standards also. Of course, in high risk CRT, we should not have any compromise. We should try to achieve the LOP level with the guidelines of company or their practices by pushing their practice to improve further. So that this should be the actually, and in any case, if you really want that the recommendations required, please try to convince them through your knowledge and your practical experience. So that is the best practice. If suppose we don't agree, we convince them and we give the recommendation. Of course, in later on they may not implement it. Of course, same recommendation, if you agree them, convince them with your practical experience and with the examples, they will accept it. They will convince their management so they can implement it. So this is the practical experience for giving the recommendations. Repeat the above procedure to the next guide word, that move to step D again until the guide words have been completed. Like second guide word is no more, less, reverse. For in case of flow, no more, reverse, misdirected, all these flows. So after completion, you have to move to another guide word, other parameter like flow, temperature, pressure. Right? Now repeat the above procedure, next parameter same, and move to the next node. So this is the total process for the Hazop that we are going. Normally, we are following in the actual process. So this is a pictorial diagram of the Hazop methodology. Maybe you will not be able to read it, but again, same thing, specify the section or stage to be executed, and same procedure we have to follow it. So I'm skipping this because it's a repeat of the discussion. Now notes. So there are few practical tips and of course guidelines also. In general, there's not a standard guideline for making the notes, but based on the experience and for practical tips, definitely you can follow that guidelines and you can uh, define the nodes. So nodes are specific section of a process analyzed to identify hazards and operability issue. So nodes are specific sections. So generally, suppose we have 10 section in the process. So in the terminology of Hazop, node is you can consider the one section only. But of course, there are some guidelines to define the section. So suppose you have operation unit, so that can be considered as a one node or can be considered two or three nodes. So that's based on the concept of the nodes. So nodes are specific sections of a process analyzed to identify hazards and operability issues. Nodes can be defined visually by highlighting the desired areas on the PNID. PNID का शेयर कर दो find कर दो DPMC का layer protection. Okay, nodes can be defined visually by highlighting the desired areas on the PNID. So basically, our approach is like that. Whenever we just see the process, we just try to see uh, the complete process and try to divide in different sections based on the approach and concept. And after dividing the nodes, we just mark it with the colors, different colors. So that can be easily identified. The basic objective of node is to make the boundaries, to make a section which can be easily handled in the particular Hazop nodes, and marking Objective is just we can ensure that all the streams are covered in the Hazop of that particular node. So these are the basic objectives. So when we mark all the streams on the pipelines or pipings, so during the Hazop, we ensure that all things are covered during the brainstorm session. So that is a basic objective. How to determine the node scope? So that is a very important thing. So node size depends on the facilitator's experience, understanding of process, and or the complexity of the process. So in the previous step, nodes can be defined by visually by highlighting the desired areas on the pin ID. So we indicate that indicates what equipment and instrumentation are within the node boundary. That is the basic objective. Now coming back to how to determine the node scope. So purely based on the experience, understanding of the process, and some few basic tips. So this also we will explain in the 40 hours advanced PH and HAZOP reader course. So you can advance your skill. You can learn more about the process safety in our 40 hours advanced PH and HAZOP reader course. We will share the schedule also. Right now it's in the design stage. So we will plan it out and we will share it. That this is apart from the every one day training in every month of this year 2026. Guidelines for deciding the Hazop nodes. We have the few guidelines for deciding the Hazop nodes. Follow the design intent. Use the pin ID as a primary basic. So nodes normally we mark on the pin ID. So that is a primary basis for nodes. Change in the process condition. So new node. Basically, what happens? There are different guidelines. If process condition change like pressure changes, so we make a new node. Mainly, these concepts we apply in the refineries and crude oil sectors because there may be a 4 to 5 paint array covering one single pipeline. So in that case, whenever their pressure change, normally we change the node. So that is the first concept. When there is a pressure change or process condition change, we change the node. Process condition mainly pressure. Please keep in the mind. In some cases, you can consider other process conditions also, but mainly pressure. Then control valve pumps and compressors that we have to market. Node size should be manageable. That is important thing. Then similar lines can be grouped in the one node. Safety critical sections need clear nodes. Start and end points must be clear in the nodes. That we do through the marking the node with the different colors. Now that is the first guideline. Then when there's a change in the conditions, so we change the node, right? The second another guideline is that suppose it's a different sections we have in the nodes. Like say for the example, we have the reactors, we have the distillation column, separator. So considering the term of that particular section, like for each reactor's reactions, we can consider one node, which includes the reactor, reactor, heat exchangers, pump, collection receiver, or transfer pumps, reflux drum. All we can consider in one node. When we change the equipment, we can make it separate node. Again, depending upon the quantum in that particular node. Similarly, distillation column, we can have a separate node. Absorb scrubber system, we can have separate node. Utility system, we can have separate node for each utility system. Now, basic expertise required or experience required in making the node, like basically say, as I said that different companies have different level in the implementation of PSM. So if you are in initial years, like 3 to 4 years, so you have to select, you can select a longer node because lot of things are required, teams involvement required, management cannot immediately uh, spare the team, your financial resources. But if you are in 5 to 10 years, of course, your node should be very specific and limited to the equipment that help us. So in case of you had means advanced stage of PSM, so of course equipment also you can break down like storage tank, receiver, separate nodes. So, in my experience of doing a lot of HAZOPs, I found that few companies we did longer notes also, and few companies just for one equipment we spent 2 days also in the HAZOP studies. 3 days also we are spending for the HAZOP study. So it's depend upon your process of implementation of PSM. But only thing you should keep in mind that continuously we should target to improve every year at least or every 2 years our level of the PSM implementation has of study and different studies. So that is a basic concept in deciding the nodes. Okay. Now you can see this is the example of node marking. We have total 6 nodes here. First one is in the blue line. So in that case, you can see that okay, out of 6, only 5 nodes are here, and one node is in other drawing. So we have total 5 nodes: 1, 3, 4, 5, and 6. You can see first node with the blue color that is receiving the material. There is a reaction vessel, then there is a distillation vapor phase going to heat exchanger, not distillation, sorry, it's a heating, then going to heat exchanger condenser and collection receiver reflux also. So this is the one node. Bottom of reactor going to filter, I think. So that's another, that is part of the first node. In node 3, you can see there is a one receiving a process vessel for the particular chemical. Node 4, of course, that is one more stream coming to the reactor. Node 5 is a green, that is the bottom of the receiver. And node 6, again, is another part that is filtration system. Okay, so this is we can say like this we can divide the nodes. So ideally, in general, average what I can say, in each node we should have maximum 8 to 10 streams. That is also way we can define the nodes. If very less streams, so quality wise no issue, but your timing for Hazop will increase because you have 20 parameters, so you have to do for that node which having the 2 to 3 streams. So your time for Hazop will increase. So optimizing the time, at least you should have 8 to 10 streams in each node. Stream means like you can say in this case node 1, so we are receiving that raw material, that is one stream. Vapor heating and vapor going to condenser and coming to reflux, that is one stream. Another stream is heating of vapor going to condenser and receiving the collection vessel, that is another stream. Like that, maximum you should have 8 to 10 stream. And optimizing case, you can do one node in a 4 hours one session. In general, that is practice. But of course, if you want to improve it, you can do one node in 6 hours or 8 hours also. That is depending upon your company requirement and company's level of PSM implementation or health of study. So this is the basic in the nodes. Now coming to the design intent or design intention. The team defines the design intention, the expected operating range and purpose of the node. So basically, so design intention, if we say for stream and as we say for complete nodes, so that's a different thing. So for complete nodes, in case of our previous example, if you go back to that example, suppose this is a reactor, there is a reaction going on. So we can say design, in case of describing the design intent of this node, we can say particular raw material feeding 500 kilogram per hour speed, heating and maintaining the temperature of 70 to 80 degree, pressure 10 to 15 mercury of mm. This is basically operating condition for that node. In addition to this, condenser inlet outlet temperature we should mention there. So inlet may be vapor. Say it is a particular chemical vapor, toluene vapor or petrol vapor. So inlet temperature is up to the equivalent to its vapor temperature. Condenser outlet should be a liquid temperature of that particular. So we have to mention inlet and outlet temperature of the condenser. We can mention the steam consumption also. We can mention the retention time also of that this particular chemical or batch. In case of batch, it's a batch time. And total collection in the receiver after the heating, that also we can mention in the note. So these are the basic things which we have to mention as a design intent in the particular node description. So any condition outside this range is treated as a deviation. Say now we discuss that. So say for example that feeding of raw material A 500 kg per hour. So if we are feeding 400 kg per hour or 600 or 700 kg per hour, so that's a deviation. So that deviation is considered, and that we have to evaluate. So it's a no flow or more flow or less flow, right? A good design intention links directly to drawing and includes detail about the equipment, material, condition, flow, and controls. It describes not just equipment, but what should happen in that section of the process. So in case of basically good intention means we have to mention the drawing number also along with the node description. Detail of the equipment, like it's a say for reactor, so it's a agitated reactor, it's a pump, so centrifugal pump, positive displacement pump, rotary pump, with the capacity of the pump, specification of the pump, like specification means mainly low capacity, motor HP, all these things, MOC. Condition of that reaction, so like temperature, pressure, all these conditions. Flow, like raw material flow, vapor flow after the heating, reflux flow, collection flow, and controls make shutdown, whatever the shutdown systems we have, that we can refer, we can make a separate list of each node, or we can identify the, we can list out the shutdown numbers in the intention. Like that, we can define the controls. So it describes not just equipment, but what should happen in the section of the process. It gives a clear-cut idea. So this will make and help team in proper evaluation of the deviation. And later on during the reference also, they will have the clear idea what the conditions are considered during the Hazop study. So it's a really a single point and readily available document for the later on reference, for training, for incident investigations, for troubleshooting, that we can, it should be self-explanatory and in detail. Now coming to the Hazop deviation. चैप्टर 5 में क्या है? Now deviation, that is basically, as we said, that guide words and parameters combination is a deviation. So guide word, no more, less, as well as. So we have the definitions also, and in detail explanation of each guide word we will share in the 40 hours course. So there you can have more learning about the guide words. So parameters, of course, minimum parameters, which includes flow, temperature, pressure, level, and composition. But as I said earlier that, see, we do only Hazop in the company as a part of process safety management, then we should consider additional guide words like viscosity, contamination, then fire and explosion, hazardous area classification, then startup procedure, shutdown procedures, emergency shutdown procedures, sampling procedures, mechanical failures, leakages, utility failures like nitrogen, air, instrument air, process air, general air, power failure. All this we should consider so that major hazards can be identified through Hazop. Of course, if you have other studies like URA, POTI, COMA, LOPA, SEAL, in that case, you can concentrate on the minimum parameters like flow, temperature, pressure, level, composition, all these things. So, or you're in the beginning also, then also you can concentrate on 5 or 6 parameters and you can start with that. But it is advisable later on you start adding every 4 to 5 parameters in 6 months or years. So that will improve your Hazop study. So These are the basic things. Now, I recommend if you're a beginner in the Hazop study, so please make a table of the metrics. We can say metrics of the your guide words and parameters for each node. Because what happens if you're in the beginning stage of Hazop, so there will be a lot of argument in deciding the deviation also, like no flow is applicable or not, mode flow is applicable or not, reverse is applicable or not. So in that case, what I suggest, if you prepare a matrix, like you just write down in x-axis your parameters and y-axis uh, this guide words, and just make a matrix with a cross mark which are applicable. Like your no flow is applicable, just mark X in the intersection part. If more flow is like yes, you can say for yes you can say you can tick it, check it, and for no you can just make it cross. So like that for each deviation, like say flow. So if no flow is applicable, make it tick. More flow is applicable, make it tick. Reverse is not applicable, just write down cross. But why not applicable? Just you have to say driving force is not available. So that we have to ensure it. Similarly, misdirected flow not applicable, just cross it and just write down that dedicated systems are available. So there is no possibility of misdirected flow. So be specific when you make a matrix also. You just can write down in the matrix itself or during the revision also. So best thing is make it metrics in advance if you are in the beginning stage of the HAZOP, say for initial at least 2 3 years. So you will save the time during the workshop or brainstorming session. You will not have to spend much time in deciding whether this deviation is applicable or not. Again, you can be open if any participant explain the requirement of that particular deviation which you consider not applicable. You can add it later on also, but at least you can save most of the time during the workshop session. That is a basic concept of making the metric for the beginners of the HAZOP. Yeah. So now next step is identifying the cause. So if your scribe is experienced, so I always advise that he should list out the cause before the workshop. So when you will do the workshop, you will feel or you will find that 70-75% of cause are already identified. So you have to spend time in the brainstorm for less of the 25%. So that will save the time. Because say for pump, so there is standard causes are available. No flow, so basic cause is suction failure, discharge failure, or pump failure. So that you can identify in the before the workshop. Similar things repeating, you not have to spend the time during the workshop. That is a basic concept. Now, after identifying the your previous step, completing the previous step, like making the matrix of guide word and parameter, we have to move to the identifying the cause. That partly in the preparation, partly in the workshop. So after identifying the deviation, the HAZOP team determine its causes. We have to be very specific in identifying the cause. Because say one basic fundamental thing is that when we say cause means it's a failure of system. Now it's a failure of system. So basic fundamental principle that we have to keep in mind that our safeguards cannot fail. So we cannot consider safeguard failure in the cause. That is a basic fundamental principle. Just keep in the mind. So if you say you have the pressure safety valve, so you cannot say the failure of the pressure safety valve can release the pop-off, unintentional pop-off of the pressure safety valve, release the flammable chemical and fire. There is a possibility of fire. So you cannot take PSV failure in the cause. But there is again one definition. Say your safeguard is a basic process requirement, then we should consider this as a we can consider that a failure also, can consider in the cause. Like for the example, suppose we say that we have to maintain the temperature of the reactor 60 to 70 degrees centigrade. For that, we have safety instrumented system, that is SIS, means automated system, means we have the temperature sensor in the reactor which is connected to the control valve through the logic solver and other hardwares. So, which gives the signal to the logic solver, and so logic solver again gives the action to the control valve. We have the complete loop. So we call it as a safety instrumented system. This is a temperature. Can call it also as a temperature controller or temperature controller loop. So this is a one loop. So here our objective of this loop is to maintain the temperature, say 60 to 70. So if there is a reduction in the temperature, so detector will detect and give the signal to logic solver. Again, logic solver give the send this command or action to the control valve, and accordingly, if there is a decrease in the temperature, control valve will open. If there is an increase in the temperature, control valve will close. So this is the basic process requirement to maintain the temperature. In this case, basically we can consider the malfunction and failure of the control valve, temperature control valve. It can be stuck closed, can be stuck open. And same thing if in other deviation, same thing we can consider as a safeguard also. But not in same deviation. Because in same deviation, we are considering the failure of that temperature control valve. We can not consider that as a safeguard or protection layer. But suppose in other streams or other deviations, we can consider this as safeguard. So normally, whenever there is a process control related layer is there, or we can say it's a requirement of the process control. In that case, we can consider this as a safeguard. Layer of protection can. Okay. So I will explain later on with the chart of the layer of the protection diagram. So at this stage, just consider that if any control system, automated system is used for process control, you can consider the failure of that system and you can consider the cause in the cause of that failure. So basically, cause means failure of the system. You can say failure. Failure can be human error. So you can consider human error. But again, there is a guideline for the human error also. So any unintentional human error. Intentional human error cannot be addressed with the Hazop. So we have to consider that. Any unintentional human error can be considered as a failure. And we can say human error, inadvertent opening and closing of the valve, that can be considered as a cause. Cause can be pump failure, cause can be your agitator failure, cause can be anything. But of course, should not be a safeguard. Cause should not be a safeguard. Just keep in the mind. So that is the first thing. List multiple possible causes as each can lead to different consequence. For examples, pump failure due to mechanical issue may cause both loss of flow and leakage, while electrical failure may only cause loss of flow. Yeah. So basically, there can be two approach, but there is a one approach. So there can be two approach for risk assessment or Hazop for particular deviation. That first approach is that we just list out one cause, we then evaluate the consequence, identify the safeguards, and complete the Hazop. Second approach is that we list out all cause first, then do one by one Hazop for each cause. So most practical and possible practice is that we list out all the causes first for that particular deviation, not for the all deviation. When we take one deviation, list out all the causes, and do the Hazop for each cause. Doing Hazop means then evaluate the consequence, list out the safeguards or parameter protection layers, do the risk ranking, and complete up to the reaching the LOP level. So I'm using LOP word very frequently. LOP means as low as reasonably possible and practical. See, in any case, any manufacturing site is a business organization. So profit optimization is, of course, their objective. They have the practice or policy to do the risk assessment, but we have to check the feasibility, profitability of that particular recommendation. So what happens if we have any doubt or management says this is not feasible? So we can do the cost benefit analysis of that particular recommendation, and we can say whether this recommendation should implement or not implement. So basically, this is the philosophy. So of course, so that is why we use word LOP, as low as reasonably practical and possible. So doing Hazop till the ALAP region or achieving the ALAP, right? So now coming back to the list multiple possible causes as each can lead to different consequence. For example, yeah, I'm getting the feedback also, good suggestions and good point to note in the chat box. So really thankful to them. Uh, of course, there are a lot of things to cover. HESOP is a big topic. We are planning 40 hours workshop. Again, there also we may not be able to complete all the things. But thank you for your consideration, sharing the feedback, sharing the points which I miss in the workshop. So please continue to share. Thank you very much. So yeah, of course, few users are also sharing the standards also. So thank you for that. Thank you for the input. Grateful to you on the behalf of all the participants. Keep continue sharing these things. We'll try to summarize it and we will share all this thing in the our community also, and of course all the question answer in the we will record the video and we'll share on the YouTube also. So coming back to list the possible causes as each can lead to different consequence, right? So we have to list out the causes. When identifying causes, focus on basic process control system, not safeguard. Cause should be specific, technically accurate, and traceable to the root issues. Example, valve XYZ struck close. So you have to say struck close rather than equipment failure. So this is how we should write down the cause also. We cannot say XYZ valve failure. XYZ valve stuck close or stuck open. You have to define it properly. Okay. So my team is just reminding me that we will have lunch break after 14 minutes. So thank you for that reminder. Definitely will take the lunch break because hope everyone is hungry. Uh, so now going to the top of the causes. So causes can be mechanical, instrument, process failure. Just reminding the mechanical, if you see again this second point, pump failure. So pump failure can be electrical or mechanical also. So in case of mechanical failure, we can say damage to the your rotating part, impeller or anything which is leading to the flow, or electrical means just failure of the motor. So both in both cases, our safe the consequence may be differ, and safeguard or layer protection may have a different one. So we have to be accurate in defining the cause. The type of causes, again coming back to type of causes. So mechanical, instrument, process failure, human error, operational mistakes. So anything, but again we have to keep in mind that it's a process part, not the safeguard part. Safeguard cannot fail. There are two philosophy or two principle that we say why safeguard cannot fail. First thing is that we believe that we maintain the safeguard throughout its life defined life. So maintaining means maintaining by following the preventive maintenance practices, inspection and testing as applicable as per company guideline or your statutory requirement. So preventive maintenance, your inspection testing, you are regularly doing it, or you are regularly doing your inspection schedule also. So that is the first part that cannot fail. Second, if you recall our initial discussion, so regarding the probability of failure on demand, of course, every safeguard, every element has a probability of failure on demand, and based on that, we design our that deviation. We do the risk assessment, and that is why we require sometimes three safeguards, sometimes four, sometimes five, sometimes six. So that is the basic thing. Because if our severity is high, we need more safeguard. That is the basic reason, that because probability of failure of particular system, say for shutdown system, it's a once in a 10 year, and we have to achieve once in a 1,000 or 10,000 years. So we have to add more layer to reduce the probability of failure of complete system. So that is the basic concept for risk assessment or any risk assessment, or mainly for the Hazop also. So now type of the causes, we go to the next slide. So next, identifying the causes. Again, same thing, detail of these causes we will again learn in the 40 hours advanced PHE and Hazop course. So if you are interested, we'll share the registration link, maybe next 1 week or 10 days, so you can join it. We will share all our uh, 2026 training program from February to December also, and this additional 40 hours registration link within the next 15 to 20 days. So please remember to sign so that you can join in time. Now, evaluating consequence. So evaluating consequence means once causes are identified, the Hazop team evaluates their consequences. So I just explained few points in the beginning of the workshops or during the workshop that how we should write down the consequence. So just recalling, basically ultimate consequence should be in normal in four category. So if you are starting again, so you can consider human asset or you can add to environment and later on repetition. So ultimate consequence should be either impact on human being, impact on environment, impact or asset loss, and your reputation of the company, your impact on the reputation. So in each, and suppose in each deviation we have one cause and we have for three consequence. One is related to health, one is related to environment, one is related to asset. So please write separate consequence of each and do the head of the rest of the step separately for each. Same fundamental principle that just write down three consequences first, then evaluate each consequence one by one, like we said for the cause also. So please remember to follow that procedure. Now, once causes are identified, the HAZOP team evaluate their consequences. Consequence must be specific, detailed, clear, and analyzed for both immediate and delayed effects. Consequence must be specific, detailed, clear, and analyzed for both the immediate and delayed effects. Should be. So escalation should be there. We can just write down that immediately may lead to fire, may lead to release, and delayed ignition may lead to major fire hazard. So like that, we have to start with the initiating event. We have to write down each step, as I discussed that increase in the temperature, leading to increase in the pressure, leading to uh, pressurization and damage of equipment and release of flammable material LOC and immediate ignition, this fire, delayed ignition, this type of fire, all this you can write down. Delayed ignition or reaching up to boiler house may lead to this one, like we have seen the video also in the beginning. So we have to write down detailed consequence, plus we have to write down all the conditions which we considered. Suppose we say at a particular petrol, we are considering the example of petrol. So we say that it's increasing the pressure. So we have to find out what is the pressure of petrol at increasing temperature. Suppose we say we are using the LP stream. So that maximum pressure will be 3.5 kg or bar in the LP stream. So in that case, temperature may rise up to 135 to 40. So we have to check the vapor pressure of petrol at 135 to 40 degree. Suppose it's a 10 bar, and we say that the reactor design pressure is 5 bar, so we can say damage, right? But suppose our temperature is reaching the 10 bar at that particular 135 to 40 degrees centigrade, and design pressure of equipment is 15 bar or 12 bar. In that case, we cannot say damage. We can say minor leakage also because of increase, because normally operating pressure is low, reaching sometimes, so it may happen, it may possible that there is a minor leakage. So in that we can consider. So we have to be very specific. We have to write down the vapor pressure data at LP steam pressure. That is, we should say that LP steam pressure is 3.5 bar, considering 140-degree temperature. Vapor pressure of petrol is this one, and design pressure of equipment is so and so. We should write down in the consequence. Then it is very easy to understand later on whenever who is reviewing this workshop, this Hazop report. So a specifying thing is very important in consequence, because based on that consequence we normally give the severity. We define the severity. So very important to specify your system. But just want to add that there are very confusions at what pressure equipment should damage or burst. So suppose design pressure of equipment is 12 bar and operating pressure, yeah, abnormal pressure may reach up to 12 bar. So what should we consider? And suppose it reach to say 18 bar, what should we consider? It reached to 24 bar, what should we consider? So normally, say our design pressure is 10 bar, so we do hydraulic at 18 bar. But because our operating pressure is 1 or 2 or 3 bar, so it doesn't reach to 12 bar all the time. So when there's an abnormal condition, so it reaches to 12 bars, we can consider minor leakage. And it is it is proved in the research papers that in the case of abnormality, if reached to design pressure, please consider leakages only. Normally, rupture of equipment we consider at 2.5 to 3.5 times design pressure. Say our design pressure is 10 bar, so rupture pressure can be considered 25 to 35 bar. That is proven in the research paper. If you want, I will share later on. I will share later in the WhatsApp community. लिख लो ये. I will share in the WhatsApp community this particular paper, so you can just refer in the later of in the Hazop also. This is a basic concept, but of course, you have to mention what pressure we are considering, what is design or what, yeah, alarm or alarm. It's a alarm. There's a one question that it's a alarm or alarm. So alarm is for it's for monitoring or safeguarding. ALAP is as low as reasonably practical and possible. So ALAP, basically when we do the risk ranking, so every company has their guidelines. Say we can say probability of failure on demand for that particular deviation is 10 raised to minus 5 to 6 or 4 to 5. Like we can say ALAP, that is basically ALAP region. So we have to achieve that region. So ALAP is related to risk ranking. ALARM is related to safeguard, right? I hope it is clear. A good question. Thank you very much for that. Now, consider worst case scenario without assuming safeguards are working. Yeah. So basically, what happens? May have experienced that when you do the Hazop operation, teams say that if there is a severity for 4 or 5, it's related to major accident. There's a 1 or 2 safeguard. They say that sorry, a safeguard has, so it will work. So no need to think of other safeguards. So basically, consider worst case scenario without assuming safeguards are working. So normally what happens, we consider worst case scenario considering potential consequence. As I said one word in the risk ranking, we do the risk ranking after the potential consequence also. So basically we have to see the potential consequence. What can be the potential consequence without considering any safeguard? That consequence we should write in the consequence column. Otherwise, you will face the argument from the other team members that this scenario cannot be possible because we have so and so safeguards. So when we write down the consequence, we should not consider any safeguard. Please keep in the mind. Without any safeguard, we should write down the consequence. So please keep in the mind that without safeguard, we should write down the consequence. So when writing the consequence, we should not consider any safeguard. There is a question that what is difference between Hazop and HAZID? So in general, we can say hazard is a macro level hazard identification, HAZID is a micro level. Macro level, like we do for complete project. What are the case of fires, fire hazard, construction hazards, all these things. While in HAZID, we don't consider detail, we not go in the detail for the process. While doing the Hazop, we check each and every stream of the Hazop and do the risk assessment. That is a basic difference between HAZID and Hazop. Okay. Now, coming back to the topic, impacts on safety, equipment, environment, and protection must be considered. So, and that if there is a 2 or 3 or 4 impacts, so please write down separate consequence for each. A structured consequence, that is flow. So deviation, immediate effect, that is the initiating event, then immediate effect, escalation, final impact, ultimate consequence on human being, environment, asset, or reputation. So say for the example, deviation start with the no flow, or we can say increase in the temperature of the column, lead to increase in the pressure, that is a immediate effect. Escalation of this may lead to reaching of this pressure up to design pressure, leakage, crossing the design pressure, reaching up to the burst pressure, damage, bursting, release of the flammable chemical, and on ignition, fire and explosion. So here we are not considering any detector, any shutdown system for protecting this increase in the temperature, but it's a potential consequence, right? So fire is ultimate. So in case of ultimate fire, consequence fire, then what is the impact on human being? Now, considering the fatality, we should see the manning of that area, and in case of fire, how much radius it covers, which how much fatality range of radius covers. So based on that, you can consider the manning level and decide the fatality. You need not to go in detail, but just with the brainstorming quickly, you can decide person, 4%, one or more than one, single or multiple fatality. That also you can conclude. So basically, this is the way we should write down the consequence. This should be our approach in writing the consequence. So now we already discussed about the evaluating consequence. So discuss that how we should write the consequence, what we should consider in the consequence, what which information is required in the consequence. So please, now we are going to the next slide. So again, same thing in the consequence also, you will find more in-depth learning in the 40 hours advanced PH and Hazop course. So you can join, you will get the link within a few days. Now, next is safeguard. That is the difference between safeguard and IPL. Basically, there are two terminology we are using: safeguards and IPL, independent protection layer. Sometimes we call it as a control, sometimes it's a barrier. So basically, safeguard what is related to HAZOP, and independent protection layer is related to LOPA. But as I discussed earlier also, that suppose company is doing only LOPA, uh, if any organization is doing only LOPA as a part of process risk assessment, so they should include the independent protection layer concept in this HAZOP itself. Means they have to list out the safeguards which are at part of the independent protection layer guideline. In that case, at least they will be able to incorporate maximum, we can say 50 to 75% of the LOPA related requirement in the HAZOP itself. Of course, it's a totally different calculation, but after considering the independent protection layer as a safeguard in the whole HAZOP, definitely you will achieve part of the LOPA requirement. So basically, let us understand for what is safeguard that is related to HAZOP and what is IPL, that is independent protection layer, that is related to LOPA. Safeguard any device, system, or action that would likely to interrupt the chain of event following an initiating event. So if you just recall again that we in the consequence we discussed that start with the initiating event like malfunction and stuck close of temperature control valve, or human error and inadvertently closure of the manual isolation valve. So that is an initiating event. From that, there is a next event and escalation going leading to the ultimate consequence. There may be a lot of steps. There may be 3 to 4 or 1 or 2 steps. So starting with the initiating event, any device, system, or action. So like device, we can say we have device like we can have PSV, we can have NRV, we can have shutdown system, we can have alarm. So any device, any system, like system maybe scrubbing system, anything like that. Action like manual intervention. Action is any manual intervention, like we go and close the valve or open the valve, that is action. So any device, system, or action that would likely interrupt the chain of event, of course, chain of event. So our chain of event in our case, like stuck close, malfunction and stuck close of temperature control valve, or second in manual system, manual human error and inadvertent closing of manual isolation valve. So that is our basically initiating event. Then increase the temperature, increase the pressure, reaching up to the rupture pressure, damage of equipment, release of flammable chemical, then fire. So here we have to understand few things in this chain. Like suppose there's an increase in the temperature. So since if it is an automated shutdown system, so temperature alarm cannot be considered because it's a part of process control loop, and we are considering that process control loop failure. It's a human error again, so human action we cannot consider in case of any uh, 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 action related to human intervention. Okay, so now suppose there is a increase in temperature, increase in pressure. So if there is any pressure alarm, so that is a interruption, because we will get the alarm and that will interrupt the chain, because after receiving the alarm, operator will take the action. Here in that case, basically there can be if there is a different operator, of course we can consider the safeguard. But if there is the same operator, we cannot consider the safeguard, because human error, if you consider human error, there is a failure of him and he is going to take the action, then that cannot be a safeguard, adequate safeguard. So we have to keep that in mind. So increase in pressure, then because of pressure there is alarm, then there may be a PSV. If there is a PSV, so that can be considered as an interruption in the chain. Reaching to rupture pressure, then there is a release and fire. So in that case, if there is a release, then there may be a detector. So that also can, initial release can detect the early release, can detect the release and can stop the process. So that can be an interruption in the chain. If we heat detector, so that can also be an interruption in the chain. So like this, there may be different interruption in the chain, so that we can consider as a safeguard. I just here want to say that safeguard is purely related to process, related to HAZOP concept. Now, effectiveness of the safeguard. So in case of safeguard, or in case of, we can say, controls in the HAZOP, effectiveness cannot be quantified due to the lack of the data. Uncertainty to the independent or effectiveness, not considered as an independent protection layer. Right? So just please remember this terminology, because I will explain independent protection layer in the second part. So here we have to understand that effectiveness of safeguard cannot be qualified because of lack of data. We can say temperature gauge is there and we are monitoring the temperature, but if we don't record the temperature, so there is a lack of data. So safeguard cannot be effective if we don't write the temperature readings every 30 minutes or 50 minutes or 1 hour or as required. Then uncertainty to as to independence or effectiveness. So in our case, independence is like that we say malfunction struck close of temperature control valve or loop, a complete loop. So in the loop, there is a sensor, temperature sensor also. So in HAZOP, normally we consider the temperature alarm as a guard, safeguard, but actually this is not independent. So that is why if it is not an effective safeguard, not considered as independent protection layer. So again, independent protection layers like same, there are 3 or 4 alarms and same operator has to acknowledge and he has to respond. So if that person fails, means all alarm fails. So it is not independent protection layer. There we have the 4 alarms, but 4 alarms acknowledgement by one operator only. So dependency of all 4 alarms in on that particular operator. So in this case, it is not independent. But in case of HAZOP studies, so normally we consider all 4 alarms as a safeguard. But when we consider implement the independent protection layer concept, so normally we don't consider. So in HAZOP, there is a flexibility to consider all these safeguards. But when we go to LOPA, that is, then we have a concept of independent protection layer, which I will explain in detail right now. So that is why I said earlier also that if you introduce your independent protection layer concept in HAZOP, if you are not doing LOPA or SAIL in your organization, so that will help you to improve your risk assessment and make your process more safer. So I strongly recommend the companies who are only doing the HAZOP study or they are in the initial stage of implementation of PSM. Now, what about the independent protection layer? So, again, by definition, effective in preventing the consequence. Again, same thing like safeguard, independent of initiating event. So, as I said, that suppose temperature control valve malfunction stop close, right? In that case, suppose we say temperature increase and because of sensor we take high temperature alarm. So that is not independent. So in that case, we cannot, as an independent protection layer, we cannot consider or we cannot take off the credit of this. So independent of initiating event means The sensor, if there is another sensor which is not connected with temperature controller, then we can consider that sensor that is a temperature T2, say T2, T1 and T2. T1 is connected with temperature controller and T2 is independent of temperature controller. So T2 alarm we can consider as an alarm and independent protection layer. So now onward, I will call independent protection layer as a IPL. Please don't get confused with the IPL matches. So IPL, so temperature T2 can be considered as an independent protection layer IPL, but T1 cannot be. So that is a basic difference. Auditable. So auditable means we should have record, we should have documented proof of that particular IPL. So effectiveness in terms of consequence, prevention, and PFD must be capable of validation by documentation, reviewing, and testing. So, effectiveness in terms of consequence, prevention, and PFD, probability failure demand must be capable. So, first thing, we should have a document of that IPL means, sorry, document means we can say, suppose we have the pressure controller as a in IPL. So, first of all, during the installation, verification, validation should be there. Preventive maintenance document should be available. Means throughout the life, we have to maintain its integrity. So for that, preventive maintenance schedule, inspection testing schedule and records should be available. PFD should be defined and justifications. In case, say, suppose we say that our pressure safety valve, we are considering the pressure safety valve as a IPL, and we are taking the credit of two layer means it's we are taking considering probability of failure and demand, that is 1 into 100 or risk reduction factor of 100. All things are same. So in that case, we have to ensure that the liquid which is coming or chemical which is coming in the upstream of PSV should be clean or free from the containment. If it is having the containment, so we cannot take it's 100 as a risk reduction factor, but we should consider 10. So instead of two layer, 100 means two layer, we can consider only 10 means one layer. So that is a basic difference, that PFD must be capable of validation and we should have a documentation. So this is a basic difference. This is a basic difference between the safeguard and independent protection layers. So there are different rules for defining the independent protection layers. So if time permits, I will share it. Otherwise, I'm just going to the next level. So in general, we can say all IPLs are safeguard, but not all the safeguards are IPL because of safeguards cannot be quantified, uncertainty to the independence, not considered as IPL. So these are the basic three reasons. Because of that, the statement we can validate that all IPLs are safeguards, but not all the safeguards are IPL. Now, just more understanding about the independent protection layers that start from the process control up to the community emergency response. So it's a typical layer of protection explanation figure. If you see in the core, that's the first one is a process. That's a hardcore process. When any designer design the process, so they just design in out, means we can say raw material input, output, and balance, and parameters required. So that is the basic process design. Then they introduce the process control. Based on their process requirement, quality requirement, operability requirements, or company policy, they introduce the process control. So first and second part is part of the process control. I think someone is not able to see its slide, so just responding. Team is responding to you, so please be online. Okay. You now first and second part. First is the process, second is the process control. So these two combined make a part of process control only. Then start with third layer, that is alarms and operator intervention. So from third, it can be a process control, can be a safeguard or IPL. So that depends upon the design. Of course, normally it is assumed that in the CCPS also that up to two it's a basic process control. Then we start with the safeguard on independent protection layers. Third is alarm and operator intervention. Fourth is the safety instrumented system like SIS, like temperature controller, pressure controller, uh, and other controllers and other shutdown systems. So fourth is the safety instrumented system. Fifth is the physical protection, that is a relief device, PSV or like that. Sixth is a physical containment, that is a bund. Seventh is a fire and gas system, that is again related to release. Eighth is the plant emergency response, and ninth is the community emergency response. So the idea of sharing this drawing is that I want to explain you the safeguard type. That is, there are two type of safeguard: preventive safeguard and mitigative safeguards. Just to explain this, I'm just sharing this particular diagram with you. So, in general, a concept is that suppose we say it's a what basic definition of preventive safeguard. So, preventive safeguards means it prevent in general release of the chemical. Or if we go to more specific definition, that the situation up to which things are in our control, that is a or safeguards up to which level they make system in our control, that is a preventive. But when start releasing or system go out of control, so from that whatever we use safeguard is a mitigative. Say for example, so when pressure or temperature increase, there is an alarm operator intervention. So he takes the action, he or she takes the action. So he will not allow to increase the temperature, means it's a preventive. Will not allow the release ultimately, because temperature will increase, pressure will increase, go up to rupture temperature, rupture pressure, and then there is a release, damage and release, right? So alarm, which is preventing increase in the temperature, means preventing not reaching up to the rupture pressure. So it's a preventive safeguard. Similarly, shutdown system, which are related to preventing to reach the pressure up to rupture pressure, or preventing to reach the out of control situation. So that safety system, some instrumented systems are called as a part of preventive safeguard. Someone has given the reference also, CP03. So just thank you for that, and I will request him, if possible, later on he can share in the WhatsApp community group also, this group if possible and if policy permits, so that all will be aware about this. So thank you very much for that. Now, physical protection, that is a relief device. So relief device we cannot say as a preventive. A preventive, maybe suppose we consider the consequence up to release of pressure. Sorry, we consider the consequence up to fire. So maybe a relief is a preventive, but after release, normally situation not remains in our control. So normally we should consider this as a preventive, but from this relief up to containment, it's a tricky decision, because based on the cause and consequence we have to define whether it's a preventive or mitigative. But in more general cases, physical protection relief devices are mitigative, because preventive up to relief device, it's a preventive. I'm really sorry. Up to relief, this will prevent the release. If pressure goes beyond and if it's releasing, then it's not a preventive, so it will become a mitigative. So based on the application we have to see, because if it's a release in the another tank, so we can say again it's a preventive, but releasing in the atmosphere, so mitigative. So based like this is a tricky situation sometimes, so we have to just think of concept in that case, what is the basic concept of definition of these things. Physical containment, of course, it's a mitigative, because after release, just containing the flammable chemical like dike wall in the storage tank. Fire and gas, of course, it's a mitigative, because after release only detect the release, so it's a mitigative. Emergency response, plant or community, it's also mitigative. Like that way, we have to just define mitigative and preventive safeguard, right? So basic concept is that suppose there is a deviation related to major severity like fatality, one or more fatality. So in that case, concept is that there should be more preventive, minimum two to three. There should be three preventive safeguards in our deviation. So of course there is of course guideline that also I will explain in the 40 hours course. What is the basic general rules are there. Based on that we can define, but in case of major hazards we should have at least two to three preventive safeguards. If in case of major hazards we have all the mitigative safeguards, the system is not designed safe, that we should consider. And as a process safety engineer we can conclude that because there are there all these safeguards are mitigative, so it's not a safe design. So this is a basic interpretation of this diagram also, and understanding of basic process control and safeguards or protection layers. Risk assessment. Now, basically, risk assessment ranks hazards based on their severity and likelihood. And earlier I said that it's a semi-quantitative because in the risk matrix we use some figures and we do the multiplication and find out the risk. So basically, risk is the multiplication of severity and likelihood. So please keep in the mind that reduction of risk means decrease of probability, likelihood. So how we do it? So we do it by introducing different layers, different safeguards, additional safeguards. So if you can understand from this formula also, risk is a multiplication of severity and likelihood. If we reduce the likelihood, we will reduce the overall risk. Now, regarding the severity, normally severity cannot be changed, cannot be reduced. Severity can be reduced only when we remove this hazard source or we act on the hazards itself. Like suppose we change the chemical, we replace the chemical. Like our pressure, operating pressure is 10 bar, and in any case maximum it will go to 20 bar, and we design our equipment to 30 bar. So I think there was a one question from the participant related to inherent safer design. So I just want to add here, it was a really good question because it has a lot of implications in the Hazop and process safety. Basically, when we design the complete project, so inherent safer design checklist is a part of that process. We can say risk assessment or part of the HSE management or risk management system. So inherent safer design checklist is not directly related to HAZOP, but in general, when we use the terminal inherent safer design, say our process maximum reaches to, in any case, like suppose we have the LP low pressure steam supply to equipment, and increase in the temperature is because of steam only, and maximum valve opening will lead to temperature 135, 40, and that because of that, that particular chemical's pressure will be maximum 10, and we design our equipment for 15 bar, then our design for pressure is inert safe design. In that way, we call it as an inert safer design. But I agree with that participant. I forgot, sorry, his name. That normally inert safer design checklist is a different thing we use during the design stage, and that doesn't have any relation with the absorption. But interpretation is different. Like in case of, in any condition pressure will not go beyond 10 bar in any worst condition, and design is for 15 or 20 bar, so we normally call it as an inner safer design. So this is a basic thing. Now again, coming back to risk, that is equal to severity and likelihood. So severity we can change only when we replace the chemical, we replace that hazard, we make design safer by introducing like previous time I said inert safer pressure design or like that. So in that case severity will reduce if we replace it. Say in case there is a design pressure of 5 bar and operating maximum can go to 10 bar, and we replace it with the 15 bar design pressure vessel, so it becomes severity will be reduced. So that is a basic concept. Otherwise normally we reduce the likelihood, and through this we reduce the risk of the our deviation or our process. I think there is a question related to sprinkler system to the storage tank. So it's a mitigative. There are two things. One case preventive, second case mitigative. Suppose there is a fire in that tank itself, so it's a mitigative. Suppose there is a fire in nearby surrounding tanks, so it will not allow to increase the temperature, so will not allow to catch fire in that particular tank. So for that tank, it's a preventive. But in case of there is a fire and we are using the sprinkler, so in that case that is a mitigative. So just we have to see the relevance and situation and condition of that particular safeguard when it will be acting. So that is of course in few cases we have to be tricky. Two main approaches are used: two level ranking and three level ranking. So I discussed earlier also, two level ranking means mitigated risk with existing safeguard, residual risk, right, after the new recommendation. So basically what we do, we just define cause, evaluate the consequence, we list out the safeguard, then we do the risk ranking in the two level ranking. Then if risk is high, then we just do the recommendation that, and we do when finally we do the residual risk after the recommendation. So this is a two level ranking. But now new approach is that there is a three level ranking, that after the consequence we do the risk ranking, that is we call it as a potential risk. So what is the potential risk in the particular deviation or system? Then we mention the safeguard. Then again we do the risk ranking, that is the initial risk. Then if initial risk is high or not in LAP region, then we again give the recommendation, and that is a final risk or residual risk. So in this case, we have the three level risk ranking. So nowadays, people are following the three level risk ranking, and of course, this will help participant understanding the potential consequence. Otherwise, normally operation people, when we write the consequence, they say, sorry, if anyone is from the operation, I'm not blaming them, but it is because their approach during the operation is same. Whenever they feel there is any abnormality, so they feel what are the safeguards available. So that is why they are trained like this, to just check the safeguard in case of abnormality, so they feel it is safe. But when we do the hazard, we don't consider the safeguard, and we define the potential risk. So that will make clear to operation team also to do the hazard study. So this will help them in changing their approach in the hazard, like they have in the operation. So operation, I was also the part of the operation team for 10 years. So I know that during the operation, we feel that if there is abnormality, okay, how many safeguards are there, which that is our risk assessment in the operation. And if there is a one or two, we also happy, because we don't go for the severity. So it's their process, and they are doing their job in the best way, because that is way they are trained. So when we do the hazard, so we start with the potential risk to understand actual risk, and then proceed further accordingly. That is the basic difference. So this also I will discuss in detail in the 40 hours advanced PHC and Hazop course. So please remember to register that also. Now recommendation, that is the last part of this one. So team recommendations recommends a solution. So if there is a breach of standards, if the team has unanimously agreed a solution, sorry, I have one question, but I just request you, if I'm not able to give you answers, definitely we will make a video and give you the answer. So please keep patience till that time, but definitely you will get your answer. So I think there are recommendation. This question related to some sprinkler and some definitions. So please keep patience. We will give an answer to that also. With the video later on, we'll share on the YouTube channel. So recommendation is a team recommends a solution if there is a breach of standards, if the team has unanimously agreed a solution. So, of course, as I said earlier, that recommendations should be accepted by the team. Otherwise, if they will not implement it, so there is no use of Hazop. Of course, ideally, we should give this strong recommendation which will reduce the risk. But we have to see the feasibility, we have to see the company's policies, company system. Suppose, for the example, we are giving the seal 3 rating recommendation, but company doesn't have any system for classification, verification, validation, and for one equipment they have to do seal 3 rating, so it's impossible for them. So like that, we have to be practical and we have to see that risk is reduced and their system is improved. So that is the basic concept of giving the recommendations. All other problems are referred for further investigation outside the Hazop meeting. Yeah. There may be few problems like we say that we cannot quantify the release. So in that case, we have to give the recommendation for QRA, or we have to give the recommendations to review the systems or review the take the trial in the R&D. Like that, we have to give the recommendation so that further it will be continued with that deviation and they can finally evaluate the real scenario. Now, essential that all recommendation actions are unambiguous and clearly recorded. So accepted by all and clearly recorded. So again, recommendation also we should write very clearly. So normally, what happens in the recommendations also, like in cause and consequence, when we are in the Hazop session, if we write that provide the flow control valve in the so and so stream or so and so piping. So there we understand because we have discussed the whole scenario. But later on, their question may come during the implementation, which what is MOC, or sometimes if there is specific material, what should be the configuration like that. So we should be very clear that provide this flow control valve in upstream of this particular isolation valve or this temperature controller or downstream of controller, because when we give recommendation we don't see when we don't give the specific recommendation because we know we have discussed for the upstream, but implementer may be different or same, but sometime may have the issue. Some the team member who was present in the HAZOP may leave the organization also, or later on during the implementations also. So we should have clear recommendation that should be this flow control valve should be installed, new should be installed, or same should be relocated in the upstream of this, downstream of this. So like that, we have to give the clear cut recommendation. Action may be either specific or generic. Normally, it should be specific. Generic like that carry out the hazardous area classification, because we are not doing the hazardous area classification during the workshop. So we feel that hazardous area classification should be done for complete process. So we give a generic recommendation. So action may be either specific or generic. So same this recommendation discussion, you will have a detailed in-depth understanding in the 14-hour advanced PH and Hazop leader course. Now the limitation of the Hazop. So Hazop is not meant to be redesign exercise. Yeah, it is true. Sometime what happens, uh, because of limitations of time maybe or by any reason, sometime we start designing the process in the Hazop. It's a reality. Sometimes it happens. I'm normally when we are in the SO, we try to accommodate the situation if time permits. But of course, there is a limitations because we have to do HAZOP in specific period. So we cannot redesign the complete process in the HAZOP session. But sometimes it's a very minor redesign, so you can consider. But normally, redesign exercise is not acceptable. For that, I recommend that before HAZOP, you conduct a design review with the same team. And during that design review, you can discuss all the design related issues. You can give the recommendations. And after complying the recommendations, you can plan a HAZOP study. And this is a normally basic practice of design review globally. So many of the companies in India also they are doing it by different procedures. But you can have the specific workshop like Hazop design review workshop with a process engineer, senior process engineer, or Hazop facilitator as a chairman or leader, so that you can find out all the design related issues in that particular design review workshop. And after compliance, you can do the Hazop study. So that is a best practice to do. It is mostly qualitative, not quantitative. So perfect. So HAZOP is a qualitative, not quantitative. But since we are introducing the figures, so normally we can call it as semi-quantitative sometime. But real quantification is like release of chemical, spread of fire, distance, fire radius, and all these things is a real quantification. So, but here in between we are doing with some quantification like major, minor, moderate fire like that. So that is why we consider this as a semi-quantitative. But normally it's a mostly qualitative. Expertise and experience within the team is crucial to quality and completeness of a study, of course. That is the basic limitations. Normally, we require senior experts of that particular process from each department to have best Hazop study. Say, if they will send a 2 years, 5 years experience, or 1 year's experience representative in Hazop, so he will not have enough knowledge, in-depth knowledge of that particular process, which we require in the Hazop. So it is essential, and this is the limitations because of some time non-availability of manpower. Some department may send a very unexperienced person from their representative from their department, so that definitely impact on the hazard. So it's a major limitation. Cannot identify all possible hazards. Yeah, of course we should accept. Normally what happens after doing the hazard, sometime client start questioning why you missed this hazard. Basically identifying the hazard is a joint effort. Hazop expert and scribe can trade the session, but main input is required from the process department, project or operation department about the ultimate hazards expected in that particular deviation. So this was happened to me also in one of the company. They just argued about it. We had given the recommendation for that also because the real actually safety tests were not conducted like RC or ARC or DSC. So they said hazard is not properly evaluated. So this happens many times because sometimes if you may miss also because it's a qualitative and brainstorming. So combined effect. So cannot identify all the possible hazards. That we have to accept and known people to the hazard they will not ask this question. But of course, major hazard we should not miss. That is also important. So there are a few limitations for the HAZOP. Now about the HAZOP team. Normally team should not be of a big size. Maximum 8 to 10. 6 to 8 is ideal, 8 to 10 maximum. Because what happens, suppose there is a big team and sometimes we face that situation also. There are 20, 25, 30 numbers of people in the HAZOP study. So normally what happens, actually you must have seen that 3 to 4 people participate actively because they have more contribution to say, like process engineer, operation, design engineer, or project engineers normally, or sometimes R&D people. So they have more to say during the brainstorming. So they take active participation. Rest of the sometimes, of course, if there is a automation, so information engineers also play a key role in the HAZOP. So other have SOS feedback means as and when required. So suppose there's a 20, 25 number, so everyone starts speaking, so we cannot proceed with the HAZOP as per the expected speed. So that is a major issue. So that is why if we have 20 to 30 members, they want to learn it, of course they can sit, they can just check, they can observe the process of HAZOP, they can learn the discussions. But actual participation should be 8 to 10. And this learning people can write down the question and end of the session they can discuss with the facilitator or process team. So that is the way ideal number is 6 to 8, but maximum 8 to 10. So facilitator and scribe normally should be third party. Uh, Project engineer, safety engineer, PSM engineer also okay. Plant personnel, instrument engineer if his automation is there, and SOS based electrical engineer, mechanical engineer, other specialists on need basis like R&D or static mobile pressure engineer or corrosion engineer as and when required. So these are the basic minimum requirement for the HAZOP team. Now, HAZOP preparation and documentation. So basically, as I said that HAZOP preparation, it starts with the document collection in terms of reference. So terms of reference is normally we call it as a TOR. So TOR for HAZOP, any study. TOR is very important. So what happened? Suppose recently we did a one fighting system design for one of the client. So we just take the permission of their, means we can say not permission, the approval that we are going to use the Indian standards. They have given the permission. We did the complete exercise. Then later on, from their purchase team, someone called us and they said that you didn't did the design. It was totally wrong. Then we checked. Then they said that their legal team had said that since you have done based on the Indian standard ISO and so, but we need a national building code design. So as per them it's wrong, but actually we have taken the approval, so it was right. But later on discussion, and we then explained them what is the real situation. It's not a wrong, but you approved for, you have given the permission for Indian standard so and so, but we did it as per the national building code. So these things covers in the terms of reference. So that is really, terms of reference, a very important document, because it frees the idea of Hazop. What we are going to consider in the Hazop, everything can be phrased in the terms of reference, and there is a no question and query and no one, because when we prepare the terms of reference, we share with all the stakeholders, so they give the approval. So there is no question and if and but and no doubt. Yeah. So someone said that workplace safety engineer and process safety. Of course, true. Terminologies are different. We can say safety engineer, PSM engineer, workplace safety. It's a different thing, but they all are same thing. So now going to the terms of reference, so it should include objective. So define goals like hazard, design safety, compliance, all these things. What is the objective from the studies? We can list out from the IEC guideline also. And scope, specify the boundaries. So which system to be included, which subsystem to be included, what modifications can be considered in this particular scope. So we have to give the battery limits or boundaries of the particular projects. Next, guideword and parameters. So we have to list out guideword and parameters which are applicable for particular this particular HAZOP. Many of the companies have prepared their guidelines and shared that these guidelines and parameters should be included. Then special focus area, highlight critical issues for the review. Yeah, sometimes it happens that particular MOC, they have done it and they just want to explore some possibilities of providing some high level of interlocks and shutdowns. So that we have to highlight it. Or some chemical is very hazardous and they want to make it a system completely full and closed system. So and fully automated system. So that things we should note as a remark. Then team composition, as I said earlier also, team composition can be designed, defined with the 8 to 10 members maximum. Rest can be invited as a trainee or just observer, but they should not be allowed to speak during the session. Otherwise, that delays the session. Then documentation quality. So PNID must be approved for HAZOP. Yeah. Actually, if you are in the design stage, of course, in the later cyclic HAZOP also, we should prepare one stamp and we should just mark that stamp that this is approved for HAZOP, signed by the authorized person with the date. So that will be real perfect HAZOP, because what happens sometimes you have revision 3 and during the course of preparation for HAZOP, there will be revision 4 also. But since in the terms of reference we are listing that we are doing HAZOP based on the revision 3, so the stakeholder who has approved or reviewed or revised the drawing P&ID, he can comment on the TOR and can include that revision 4. So that P&ID should be approved, stamped and signed by approved person. Similarly, all other documents, it's just example is P&ID, all other documents like PFD or process descriptions, your cause and interlocks and all these things, cause and effect and interlocks, all these things should be approved with the stamp for the approved for HAZOP. Now, risk ranking. So clarify requirement and timing during and after study. So basically, risk ranking, defining the risk ranking is also a very important task. A minor uh, change in the risk ranking guidelines will make a lot of impacts. Suppose your first asset damage you consider $1,000 billion, and someone consider $1 million. So there will be a major impact in that case. Suppose refineries of $1 million may be okay, but for medium scale industry, not okay. So like that, we cannot copy it. We can copy the concept, we can follow the concept, but there is of course guideline book also. That book we will share in the group. That is a risk matrix, risk-based approach risk matrix. That is by CCPS. So I will share that book also in the group. So you can refer that book for. It's not purely for the risk matrix, but you can get, because it's severity and probability levels are defined in that book. So you can refer that book and you can design or further evaluate or improve your risk matrix of the company. So risk ranking should be clarify requirement and timing, right? Okay, there's a question: who can decide the risk ranking? So basically, uh, risk metrics can be prepared by any PSM engineer, but approval should be from the head of the department. And reference book is CCPS book is available. You can refer that book and can prepare the risk metrics, or you can update your risk metrics accordingly. And generally, all the document should be differ from company to company. Yeah. All the document should be reviewed every 3 years or 4 years. That is very important because a lot of guidelines are frequently changing. There's a question that risk metrics may change from company to company. Yes. First concept is that size of company. If it's a refinery, so risk metrics definitely differ from the medium size. Even size of companies are same, like refinery to refinery also it may change based on the company policies, guidelines, and objectives and targets. So definitely it may change from company to company. Now deliverables. So that should also be mentioned. Reports, minute sections, tracking list, all should be mentioned in the TOR, so that we can say it's a basic guideline for particular that Hazop. TOR is a basic guideline. So when TOR is approved, means our actions are phrased. Now we have to start action one by one based on the TOR. Planning the Hazop. That is the next step. So estimate the number of meetings based on scope and past studies. Yeah. So for particular company, there is a past history also. If they're doing first time, so I said that earlier that you can consider numbers of meetings based on like P and ID. You can consider 4 to 6 P and ID per day. And later on, based on your experience of past experience of your company, you can decide how many P&IDs can be considered in a day. Here, I just would like to add one more thing. When you are calculating the numbers of P&ID per day, just differ it process and utility. For process, I'm talking about the process. Normally, process you can consider say 4 to 6, and when you improvise your Hazop study, you can consider 1 to 2 also. But utility normally you can consider 8 to 10 per day. After improvise also you can consider 6 to 8. So normally utility, everything is very standard. Say for thermal heating system, of course, it's like a process. So we cannot call it as a utility part, similar to utility. But like other air, nitrogen compressor, air compressor, cooling tower, your air instrument air compressors, all this can be considered in the range of 8 to 10 per day, or after improvisation 6 to 8 units per day. Like that, you have to estimate the numbers of meetings. Another question is that risk metrics can be based on the technology or process involved. So normally it's based on the company's guidelines, corporate guidelines. You're designing first time, so you have to see the size of the company, on what can be the size of company next 10 years, because you will not redesign or this update your risk metrics every 1 or 2 years. So maximum you have to consider for 5 years. What will be the size of your company next 5 years? So based on that, you have to design the risk metrics. Define study boundaries. Again, coming back to the planning the Hazop, define the study boundaries early, like battery limits of all the sections on all the departments. Allocate resources and set expectations. So as I said that in the TOR, normally we just define the expectations and objectives, goals, and we just list out the team members. So that is important part. Share background materials before the first session. So scope and objective, key design documents, Hazop methodology summary, initial parameters guide words, Of course, this should be shared with all the stakeholders. So planning the HAZOP and preparation, execution, and reporting. That's the four steps. So we are in the planning now. Next is documentation and reporting of the findings. So basically, there are different approach for recording, documentation, and recording of the HAZOP. Many people use Excel worksheet. Their softwares are also available. Many softwares are available, but internationally accepted softwares are PHA Pro, HAZOP Manager, and few maybe. So you can use any of that. Latest versions are available. So during the practical session, yeah, there's a question that any plan for LOPA training? Definitely, we have the plan for LOPA seal. I will share all the list of the trainings after the session, maybe tomorrow, Monday. What we are planning, of course, month-wise and date-wise, we will share it later on. What topics we will share, our team will share to you, so you can keep your checks on in the community, so you will get it updated. Even on the our YouTube and social media, we have the Facebook, LinkedIn account, so you can join us there and you can keep yourself updated for these trainings. Now, regarding documentations, of course, there are a lot of softwares. PHA Pro, during our practical training, maybe 30, 40 minutes or 1 hour, we will use the PHA Pro. You will have the familiarity with that. But sure, doing with Excel and doing with the help of PHA Pro, it will save time. When we use the software means doesn't a calculation, but it's like for the facilitation. It will reduce the workshop time to 20 to 25%. Because if you see, if you have attended the HAZOP with the Excel or with the software, you can easily compare. But those who has not attended either of, so they will realize when they will attend, because with software, stream is tremendous. So definitely it helps. After the AI technology implementation, this will again make it faster. So definitely software will help us. Capture has so documentation and reporting of findings, capture hazards, deviations, safeguards, and recommendations. So that we are using, normally we are using PHA Pro. You can use any software available in the market. Try to ensure that this is internationally recognized. Because if you are using for your company, that is fine. But suppose you have to submit a report to your client, so your client may ask internationally accepted software, and that is also licensed version. So please ensure while deciding the software also. Keep in mind all these things. Second, ensure knowledge transfer and support audits, of course. So basically, what I feel, HAZOP is not only for the brainstorming to identify the hidden hazard, it's an opportunity for the HAZOP leader to train the team for the concept of HAZOP also for their process indirectly, just by discussing the hazards and brainstorming. Train them for thinking in a different way to identify the hidden hazards, train them for incident investigation. So it's an opportunity to train the HAZOP team in different aspects when we do the HAZOP. So definitely knowledge transfer is very important. Of course, we also as a leader, HAZOP leader, learn a lot of things during the HAZOP. Starting with the HAZOP, and at this stage, almost I have some 20 to 20 years of experience. So I can see difference in my understanding also. But of course, there are a few things which I will definitely share in the 40 hours program. But we have to be practical. We have to allow the participant to speak. We respect them. We respect their suggestions. We encourage them. So that will make a difference in the HAZOP study. Now, third is a provide traceable safety record for future assessments. Of course, that is very much important. So, like your report, which includes the all the things, your executive summary, worksheet, your attendance sheet, your recommendation list, your assumptions, whatever you assume during the HAZOP brainstorm, you should write in the report. Your considerations, your exclusions, everything should be there in the report. So it will be a clear-cut report. and better reference for the future. So definitely HAZOP report, we should all write all down all these things. Structure of the HAZOP report. So there's a question that records up to what time it should be maintained. Normally, say any record is up to the life of the basically any risk assessment related record should be maintained up to the life cycle of the project. But of course, if you do the recycle HAZOP and you have considered the previous one, so you should maintain at least up to the next level of the HAZOP, next recycle HAZOP. So, but it is at least advisable because if suppose life of your project is 40 years, so you should maintain up to the 40 years. So that is a basic requirement. Of course, HAZOP report is a part of the PSI document. There is one question that HAZOP report is a part of the PSI, so process safety information. Of course, because when you do the recycle, you will revisit the previous HAZOP report also. So at the time of recycle HAZOP, it should be the part of the PSI, process safety information. Next one is structure of the HAZOP report. So executive summary, structure of the HAZOP report. So executive summary, that is the first thing. Normally what happens, say this HAZOP report will be reviewed by different level of people. Actual users, they will review in detail. But when it will go to site head or department head, so they need summary only. What was the expectation? What is achieved? What is not achieved because of some limitations? So they need this executive summary only. So what is previous risk level? Now what is the present risk level? All these things they need. That is their basically job also. So executive summary is very important. Key finding and recommendations are very important in this case. Scope and methodology. So scope, as discussed earlier also, we just mentioned the scope in the TOR, and same we have to do with some additional reference if required in the study. So study approach and boundaries should be mentioned in the report. Team details, team members, name, roles, responsibility, and their attendance. Very important. And normally, we should not allow key persons to leave the session during the session for any important thing, because what happens if they are key person, they are discussing and giving input regularly to the brainstorm session. If they are not there and input missed, so that may lead to of course unidentified hidden hazard. So key person's presence is really very much important and advisable. That should be if there is this HAZOP is going on within the company, should switch off the phone or put it on the silent mode. No phone should be allowed, and normally should conference should be closed. Advisable to keep the workshops out of this company. That is best practice. Suppose you have two, three different units. If you are in unit one, please arrange the workshop in the unit two or unit three, so you will have lesser disturbance. Or you can arrange the hotels also and work when different venues. Worksheets, node by node analysis, deviation, cause, consequence. That's definitely, we have the sample of worksheet also. I will share it to you. So a worksheet is very important for the record keeping. Appendix, you can append is PNID, attendance sheet, photos of workshop, references also if required. All this should be mentioned in the report. So this is format of the worksheet with three level of risk ranking, right? So say if you see first, that is a start with the project. So project is HAZOP study for refinery, HAZOP study for ABC plant, like that. Then in that plant we have different nodes. So the node which we are discussing will reflect in second line. That is node. This is actually the image of the PHA Pro software. So second, otherwise if you to design the Excel, it's a very difficult, like project node and PNID number. Table you can design, but first initial designing becomes very complicated. So second part is node which we are referring, that is node 1, then PNID number, that is PID 1. Then reference number is 1 and 1 means one first node, first deviation. 1 and 2 means first node, second deviation. 1 and 8 means first node, 8th deviation. Then there will come a deviation. So deviation will also have the number. Here it is not mentioned because it's a blank worksheet, but when you will do actual study, you can check it. So deviation also have the number. Then for each deviation, you have the cause. Suppose first node, first deviation, so 1 and 1. Then there are 4 causes in the first deviation. So 1 and 1.1, 1 and dot 1.1.1, 1.1.2, 1.1.3, 1.1.4, like that. Similarly, consequence will be in the fourth place. Same numbering, more than one consequence, so 1, 2, 3, 4, like that. Then after consequence, it's an initial potential risk, right? So it's a potential risk without the safeguard. So that will give clear idea about the severity of that particular deviation. Then comes a preventive safeguard or mitigated safeguard. Then you can call it second level of risk ranking is mitigated or initial risk, and after recommendation, third level of risk ranking is residual risk. That is the third part. Okay. Now going to the next one. Inverted, right? Okay, so now I think this is basic introduction of the Hazop, but during the course starting from 1979 from ISI, then 2007 CCPS. After 2007, there are a lot of changes. Sir, from where we can find version of? Okay, there is a question that from where we can find the version of the PHA Pro. Basically, there may be a trial version, and you can purchase online. There are different vendors for this PH workshop. So you just write down Hazop software vendors, they will get the information. Or you can use the chat GPT also. Okay, actually, I am not discussing chat GPT in this session because it's an introductory, but in the detailed stage, I will discuss a lot of about the chat GPT, how to use, how to find out. We have seen that it saves a lot of time and improve the quality of workshop, because sometimes there's a query that what is the saturated steam pressure at 140 degree centigrade or 180 degree, 190 degree. So we can find it very easily with the chat box, chat GPT. Lot of things we find, property of chemicals, lot of things, a lot of calculation we can do with the help of approximate calculation. Definitely we cannot verify, but approximate with the help of chat GPT. So chat GPT will definitely change your output of the workshop, definitely change, and will be faster one also. So we normally use find out different information from the chat GPT during the workshop. I strongly recommend you to use the chat GPT, but of course your insight should be there after the outcome of the chat GPT. Of course, coming to there's a question related to eHazop. So, what are the documents required? So, here we will not discuss in detail, but I will just give a brief. So, basically, advancement and feature trends in the Hazop. So, computer-aided Hazop tools enhance consistency, documentation, and revalidation as enhanced Hazop approaches that systematically address process control systems, instrumentations, human factors, and cyber-physical interactions. So there are few HAZOPs now, which is in the line with the IS guideline, IEC guideline. That is eHazop. That is electrical HAZOP, or sometimes we call it as a SAFOP also, or SAFEN and SAFOP. So that is the same thing. Computer-aided hazard represent important advancement addressing modern plant risk. There is a C HAZOP also nowadays, control HAZOP. Control has nothing but the automation related things, just checking of that. Of course, nowadays we are doing the Hazop for the SOPs also. So that's a separate Hazop for the SOP. So there are a lot of branches of the Hazop nowadays. We can use as per our requirement. The integration of digital engineering data, advanced simulations, and AI supported analysis is expected to further strengthen hazard identification. So you may find in the future the Hazop software may have the engineering data also, because with the help of AI or some your process data also. So you can add the process calculation directly into your PHA Pro, and that will help us. So you may find in the future. So it's a future expectations, and developments are going on. So that will definitely improve our Hazop study. So regarding the documents required for the this computer-based Hazop, basically, say for electrical Hazop, we need a line diagram. Similarly, for computer, we need a diagrams of that particular systems. For controls, we need a control diagrams also. That diagram means your sensor, receptor, logic solver, transmitter, all these diagrams. So that will definitely help in evaluating that system also. So basic requirement is your particular diagram related to Hazop, electrical diagram, instrumentation diagrams, all these things. Then your basic process controls in that particular diagram. Like we have the shutdown system, similarly, there are controls in the electrical diagrams also for temperature, for overloading, all these things. So controls in that particular diagram, basic concepts, basic design basis, or we can say basic designs of that particular system. Uh, Other documents may vary as per the project. So these are the basic documents which are required. There is a question: what is the difference between HIRA and Hazop? That was already discussed in the initial stage. We will share this presentation, so please refer that presentation, and we will add in the our video answers also. Okay. Now, chapter 5, practical problems. So we are just okay. We have 1 to 2 minutes because now we have to switch over the systems and we have to just connect with the PHA Pro. So just please wait for 2-3 minutes. My team member Ayush will connect this and he will make it online. Till that time, I further humbly request all of you just to please give your feedback in the link shared for our Google business so that will motivate our team. You have to do ranking. Sorry, ranking. I'm just mixing risk ranking with ranking. There is a five-star rating. So please give the star rating and one line that how you like this initiative. So please share that. So link, my team member is sharing the link again. So please do it. That will help us in further improving and that will motivate our team to make a better arrangements next time. So just wait for next 2-3 minutes. Good. Someone is giving the answer for the difference between HIRA and HAZOP. Perfect. That is perfect. So now we will discuss the practical problem. Just Ayush is taking few minutes. Ayush will explain because I had said a lot of things. Now it's a turn for Ayush to explain the process. Then we will just go to the this session. Just a small practical of as of study. Now over to Ayush. 1 second. आप बोलेंगे या मैं बोलूँ मुझे बोलना है नहीं आप बोल दो फिर
You can turn your mic off.
YouTube का
YouTube तो on रही है.
So hope everyone is getting my screen. I'll just share the presentation. So now we are simulating a practical Hazop, like in actual how the session goes and what are the backend things we do. So we will try to simulate what a actual Hazop looks like. So here we have a practical problem. As you can see in our screen, we have taken a system, a styrene storage tank, a tanker, road tanker, and a transfer operation. So we have simulated a system where a storage tank, a styrene storage tank, is getting styrene from a road tanker. So there is an unloading transfer operation, and then there is a storage operation, and then the transfer from storage tanks that we usually call the tank farm to our process area. So now I will just share.
Now Ayush is sharing.
Yeah. Okay. Okay, so these are the general Hazop steps. I would like ask her to just go through these steps.
You want me to speak?
Yeah, just this preparation
I
and
think I have
this
already
thing.
spoken a lot about this.
Okay,
Just repeat it and we'll
okay.
go for it.
So just suppose everyone, just suppose I am the scribe of the Hazop session. So what the steps I will follow? So the first thing that I will do, I will prepare the terms of reference. I will list down all the important activities that we are going to do. I will list out all the important guidelines, the procedure that we are going to follow. So I will prepare the terms of reference. I will share it to the client for their approval. And once the terms of reference is approved, I will ask the client for documents, some important documents like the PNIDs for process description, the MSDS, cause and effect diagrams, and start preparing for the HAZOP study. So in preparation, what I will do first, I will ask the process engineer, the process team to explain the process to me. And once the process is clear to me, I will start defining the nodes and get the node approved by the head of facilitator, the chairman, which Yashpal sir is playing the role here. So Yashpal sir will approve the node list, and I will send that node list to the client for their approval also. And once the node is freezed, the node list is freezed, so I will start the node marking. These all activities are done before the start of the actual Hazop session. So all these activities will be done in back office. So I will do the node list and the node marking, and also I will collect all the material properties either from the MSDS that we generally ask the client to share, because see, many open source MSDS are available on the internet, but what actual material the client is using, they should get the MSDS from their vendor. So we generally ask the client to supply, give the MSDS what they use. Also, we have many other sources for material properties, like some standard MSDS websites like Sigma LD or PHSER Scientific. They are the ones and standard ones. The ECHA is there. They list down chemical properties of various chemicals. OSHA is there, and National Institute of Science and Technology. They also have a vast database.
Full screen.
Okay. So next we have a National Oceanic and Atmospheric Administration. This NIST and NOAA are US organization. They prepare databases for material properties. So all from all these sources we can get the data, and we will compile all these things. The preparation of study, the points 1, 2, 3, and 4. All these things we will compile before the start of the study, and then we will move to the actual health of study. Now I will just show you the MSDS sheet that we generally prepare. What are the chemical properties that we take out from the MSDS that we compile? Just give me a moment. So this is the Excel sheet. You can, if you can see on your screen, this is the MSDS we prepare the Excel sheet. We name out all the chemicals here, 1, 2, 3, 4, 5, 6, all the chemicals. Then these are the different properties that we list out. Whether if it is available in MSDS, we directly take it from there. But generally, many data are not available in the MSDS, so we go through other standard sources like NIST that I have mentioned, NOAA is there, ECHA is there. So we take the parameters from there. As you can see, critical temperature, pressures, specific gravity, viscosity, vapor density. So these are the parameters that are very essential to write down how a chemical will react or perform if things goes out of our control. So see, if the viscosity is very high, so the chemical will not free flow easily. If the density is very high, then it will tend to settle down rather than going above in the atmosphere. So with the help of these parameters, we the team decides how the consequences will be written down. So these are auto ignition temperature, flash points we mentioned, what are the TLV, STL, IDLH, immediate danger to life and health. So these parameters define the toxicity limits of the chemical. Then LD50, LC50, handling restrictions, reactivity, stability. So these parameters we list down. Now we are moving to our actual Hazop session. So in the start of the Hazop session, we generally ask the process engineer to once again explain the process to the entire team. So the entire team comes on a single page. Each one of the team members have the same understanding level as the scribe. So and the facilitator. So once the start of the session, the process engineer explains the process to the entire team, and then we will move to the actual Hazop worksheet. So now I am moving to the Hazop worksheet. I will share PHA Pro. So this is the PHA Pro screen that you can see. The first tab here is the administrative part. These are the general things that we can mention: methodology, general things, team members who are present, what are the sessions like, a day duration, then attendance we can take. So these are the some special features of the software. So we can do these things in the software only. Then we define the project. So say in a particular study, there can be a list of projects. So here we have the Hazop study for styrene storage tanks. So in that particular project, now I will move to next step, which is the node. So here I have defined two nodes based on the process. I have kept it very simple for your understanding. Just two streams, process streams in first node, and one process stream in the second node. So first node is styrene tanker unloading, node 1. Then I define the node description or the design intent that we say. This is two material streams I have defined. Styrene transfer from road tanker to storage tanks V101 AV by unloading pump P101D slash E. So this is the first stream. Then second is our operation, that storage of styrene in our storage tanks. So in first node we have covered unloading operation and storage operation. In the second node we have covered styrene transfer operation. So that is transfer of.
You can see we have two streams only, and second node we have one stream. Just for understanding, we are divided in two nodes. Otherwise, these three streams we can consider in one node. As I said earlier, total 8 to 10 streams we can consider in one node. But for our understanding here, we have divided this in the two nodes. So please go to the worksheet now. So now after design intention, please go back to the node description. So if you see, list of printer is also mentioned in the major equipment. Say first column, that's a node. Second column, node description and intent. Second, list of PIDs. So PID 910911 in first node. Second node also same PID. In the major equipment, storage tank vessel B101 A oblique B, unloading pump P101D oblique E. So here you can find the capacity and all these things for your operating parameters also in this major equipment description. Please go to the worksheet. We are in the worksheet. If you can see worksheet, so this is software. So if you start with the project, so that is first Hazop study for. Thank you very much for your patience. I sincerely apologize for inconvenience caused to you. So we started with this worksheet. Okay. So if you see, that is first project, one Hazop study for sharing storage tank. If you go to second part, Aish, please go to second node. Okay, second node is sharing transfer operation. That is node 2 and node 1. Then you will see the pin ID number. And now we have the worksheet. So we start with the reference one. So we'll just do some exercise, and here also you can just give your feedbacks. We'll try to ask you the questions also in this, because we have some time, 30-45 minutes. So if you see in the reference one, deviation list, Ayush has already identified the deviation. So let us take first deviation. We start with the no less flow of styrene transfer from road tanker to storage tank, that is V101AB, by unloading pump P101DE. So before starting, let us see the property of styrene. Do you have the MSDS, Navish? Can you find out from the online? Yeah, we have the styrene MSDS. So this is the sigma rich MSDS. So let us quickly review the property so that we will be able to do it properly. So we have to see product, that is a styrene. Please scroll down. Next information we require related to hazards. Please go down. You have to wait it because there's a delay time. Okay, fine. So now it's a, we have to see label elements. So from the label you can find out hazard pictorial. It's a flammable health hazard also. It's a danger, so that we have to consider. Hazard statements is also there. Flammable liquid vapor H226. So we have to just evaluate accordingly. Please scroll down. Now we have to see the physical properties, which includes the auto ignition temperature, MI if possible.
Recommended storage time.
Recommended storage conditions. So that is keep container tightly closed in a dry and well ventilated place. Keep away from heat and source of ignition because it's a flammable liquid. So recommended storage temperature is 2 to 8 degrees centigrade. That is the recommended storage temperature. That is purely based on the flash point. So we'll see the flash point and we can conclude this storage temperature. Next is the physical property. So physical data, it's a liquid, colorless, melting point is 31 minus, boiling point is 145 degrees centigrade, UEL upper explosive limit is 8.9, lower explosive limit is 1.1. Means if a lower explosive limit is lesser, means it's a more dangerous because easily that concentration can be achieved. So it's a more dangerous in that case. Auto ignition temperature is 490 to slight safer. Flash point is 32 degrees centigrade, so that is also safer. Scroll down. Decomposition temperature comparatively safer, not safer because ambient temperature is 45, so it's a flammable at atmospheric ambient temperature. But considering 2 degree, 3 degree flash point, it's a safer one. Solubility in water is very less, 0.32. Scroll down. It's a more, sorry, 0.32 gram per liter is more. So scroll down. Vapor pressure, relative density, density not relevant. So now we have the auto ignition temperature, LEL, UEL. Now we need a minimum ignition energy for this particular styrene chemical. So it can you find from the other resources, available resources, or you can use the chat GPT also. Just check the MI of styrene. Resistivity is also important. So we'll see the MI and resistivity of the styrene solution. So that will help us in defining the severity of this particular chemical. So there is a question that which input require mandatory for Hazop. So P&ID, of course, PFD, basic process description, and cause and effect. These are the mandatory. MI for styrene is 0.03 millijoules, so very, very low. If you consider in the winter, if we use the winter wear, so that also generates 30 to 40 millijoule. When we walk, so static charge generate having the MI around ignition energy around 20 to 30 millijoules. So it's the point is very minimal. You can refer the NFP also for same thing. So even ECHA also gives the data because normally all the chemicals are registered at ECHA. So you will find there also. So 0.3 is very, very low. So it's more dangerous in that case. What about the resistivity? So resistivity for styrene, I was just trying to find out online. We can refer standard MSGs also. ECHA is also standard website for this reference. But considering this, typically in the range of 10 to 16 to 18, very, very high. See, in any cases, if you refer Indian standard, so high resistivity is more than 10 to 10. If you refer NFPS, I think it's a 10 to 6, or IC also same. So in any case, 10⁻⁻20 is much higher resistivity, means there is a low conductivity of the static charge within the styrene, means accumulation of static charge is there. So there is always possibility of discharge. So this is, we can say, more dangerous than having the less resistivity. Mi low, resistivity high, it means a very dangerous combination. So we have to take care of all the things while handling this styrene. So static earthing, your lightning, your other charges, that has to be taken care. Even discharge of static charge from the human body also to be taken care. So we should have a human discharge point there also. Anyway, we'll see in the our Hazop discussion. So please go to the Hazop worksheet. So this finding these properties data, ChatGPT is really very helpful. That is why try, if you are using, that's very good. Otherwise, please start using the ChatGPT. That will help you in finding the data. So in the 40-hour session, we'll take few properties and I will guide how to find the properties or some information from the ChatGPT. So now coming back to the deviations, now here I will request you to participate in the session by sending the messages. So like deviation is no flow of trirene transfer from road tanker to storage tank by unloading pump. So in the line we have manual isolation one. Yeah, we have in the transfer unloading lines pump and suction. We have a manual isolation valve or shutdown. I is sharing the P&ID. So please go to start from the tanker. Manual unloading valve in the suction and discharge line. Of course, someone has said that pump failure. So definitely one cause is a pump failure. Second cause, true, valve close. Someone has said that valve close. That is also true. Valve closing. Freezing. What is the freezing point, Avish? Anything information available? So there are, let us write down one by one, then we'll go to search the freezing point. So please write down. Minus 31. Freezing point is that same thing. Minus 31. So it is not possible till our ambient temperature is less than minus 31. So that we can rule out. So, but thank you for your thinking and understanding. Please go to worksheet, Ayush, and please write down the causes. So I think you have shared here. The first cause is pump human error, that is inadvertent closure of the manual isolation line from tanker of the human error, inadvertent closure of the manual isolation valve in suction of the pump P in line from storage this tanker to pump. In line from tanker to pump. Like this, we have to write down the cause. It should be clearly descriptive. So in human error, inadvertent closure of the manual valve, or you can write down manual isolation valve in suction of the pump P in line from tanker to pump. Right? So please write down another cause now. Second cause is someone has said that pump failure. So mechanical and electrical, we can combine it, no issue. Just for today's practice session, but advisable if you can do it separately also. Now third is same human error, inadvertent closure of manual isolation valve. Okay, what is the line size? That is a question. So just hold on, we will just share. Strainer choke leakage, we'll see strainer also. So I is just sharing the perfectly, you are going perfectly that these are the queries we should have. So line size is there a line size? So as per, it's a 4-inch line size. If you see MS 15CO2-4 inch -1139 is a line number, 4 inch is a size, 15 CO2 is another some information, and MS is a metal of construction. So line size is 4-inch perfect. And do we have any strainer in the line? Yes, we have the strainer. No? This after the 4-inch valve, we have the strainer. So we have the strainer, we have the FQI, means totalizer is also there. So please go to the worksheet. So, of course, so strainer chalk can be one of the cause. True, you are perfectly right. Strainer chalk can be one of the cause.
Okay.
So we have identified four causes, perfectly true, perfectly right. So now let us evaluate the consequence and other things. So consequence without safeguard. So what we say that manual isolation valve is closed and we have started the pump. It means possible dry running in the pump may lead to pump cavitation. As someone said rightly that impeller damage or seal damage, so we can say pump damage may lead to pump cavitation and pump seal and impeller damage. Any information about single mechanical seal, double mechanical seal? Let us consider a single mechanical seal. So please write down the single mechanical seal in the bracket. So impeller and seal damage. So we are considering a single mechanical seal. Pump not primed. Actually, in such type of case, uh, say normally procedure is that they have to close the suction and discharge valve to prevent any leakage from the pump and spillage or release. So that is why sometime pump may not be primed because closing of the suction valve. They if he forgot to open the operator forgot to open the valve, in that case not prime. Okay. So I think voice is okay, Jasmine?
Yes,
Voice is okay. Fine. Thank you. So again, going to the consequence, possible dry running in the pump. P101DE may lead to the pump cavitation, leading to pump impeller damage, seal damage, release of the styrene may lead to fire hazard.
Major, moderate,
Hmm?
major, medium.
I'm coming to that. May lead to fire hazard. Now, fire, there may be minor fire, major, medium fire, or major fire. So, normally in this case, we assume that normally for quality, if there is no guideline, no data of QRA, so we consider that minor fire is from the flange leakage, medium fire is from the seal or these type of leakages, and major fire is from the rupture. So here it's a we can consider this as a medium fire, but these things we have to write down in the executive summary. So I has taken the note of this and he will write down in the executive summary. So it's a major fire, sorry, medium fire. So in this case, normally suppose we have risk ranking severity 1 to 5. So 5 by 5 risk matrix. So severity maximum is 5. So normally we take the assumption that leakage means we will take the our severity S3, medium S4, and major S5. Considering that our response plan is perfect, your fire protection system is perfect, we consider these things. So that is the basic assumption we have to write down in the report, right, Aish? So we are considering here a severity 4 and probability. Probability is purely based on the cause. Sometimes we take the probability based on the risk, consequence also, but normally cause is a perfect thing. So human error normally it's L4. We are considering L4. We have assumed that human error will consider once in a
Once in 10.
10 year because we are considering L5 is once in a year. So human error we are considering once in a 10 years. So L4, right? So risk ranking we see potential is a very extremely high. So now we have to give the recommendation. So we have to start with the preventive. So first thing is preventive. We can see we can check for the dry running protection. So do you have the dry running protection, Aish?
We can assume.
Uh,
Dry run
Considering
protection
this,
provide.
so dry running, there are two type of dry running protection. Either low current. So in case of low current, we have to see whether motor is of less than 5 HP or more than 5 HP. If more than 5 HP, we get the enough span to give the low current. Otherwise, operating current, low current range will be very minimal. So if less than 5 HP motor, so range between operating and low current will be very low, so we cannot consider there. But if 5 HP or more than 5 HP, so we can consider. We are considering that here dry run protection for the low current is available. Second, dry run protection is related to flow. So we can provide the flow switch also. And because of low flow alarm, we can give the dry run, we can give the interlock to stop the pump. So that is another dry run protection. So dry run protection can be on the current, can be on the flow, and be on any other pressure also, but more relevant is flow or current. So dry run protection provided to pump. So we are considering this as a safeguard. And since we are incorporating independent protection layer concept also here, so Ayush has written that RRF is 10, that is a single layer. Or otherwise, in other words, we can say probability of failure and demand is 1:10. That's once in a 10 year. Okay. Any other safeguards here? Any other safeguard, Ayush?
Okay. Flow. This indicator.
Yeah, we have the totalizer. So totalizer, but Ayush, that will give quantity. Flow will not be there. So we should not consider that as a safeguard. Any other safeguard? Of course, fire protection system, we are considering that there is a fire gas detectors are there. So let us write down that styrene fire and gas detectors are available.
Mitigate.
Mitigated. It's a mitigated because in mitigated, because dry run protection is a preventive, but FNG detectors are mitigated. Fire and gas detectors are mitigated. Styrene gas detectors are available. So here also, if you go in detail, so gas detector we cannot put randomly. It should be through the gas mapping study, or we should give based on the just distance covered by individual fire and gas detector and mapping on the layout. So styrene gas detectors are available. So we are taking the credit RRF1. Actually, say we can consider the fire protection system also, but that is not the design basis or design causes. So normally we should avoid considering fire and gas detector emergency response plan. We should try it through the hardware, software, or design aspects. So here we have the two. Suppose we just do the mitigated risk ranking, to severity again will be 4 as 4. Ayush, please go there. Yeah, spillage connect kit, that is a good safeguard. So definitely we can consider this. So we are doing just risk ranking with these safeguards, and then again we will add a few more safeguards. Spill control kit. Yeah, we can consider this. So S4, and we have the 3 cadets. So L4 will reduce to L1. So it's not tolerable. Yeah, line and flange leakage also can be considered, but just I want to add few things here. Any leakage that we address to hazard area classification, right? So basically that we consider during the hazard area classification. So please do not consider line leakages in the as a cause. I understand because of leakage there will be no or less flow. I think that is what your response by Shweta Solanki. I think that is one. If you have any other response, so please let me know. Otherwise, what I understand, line leakage and low or less flow, that normally we address in the hazardous area classification. Probably hazardous area classification will be our next topic in the February. Hope so. Maybe in the March or April also, but that is one of the topic. So by these 3 safeguards, yeah, there is a question how we decide the RRF. So I please share the LOPA guideline, CCPS layer of protection. There is a guide for the layer of protection analysis. Ayush is sharing that book. There is a table. From that table, we can consider these things. So just hold on, please. This is a. Can you go to the topic first, Ayush? First, this title of the book.
Not this one.
Huh?
This one.
This is the title of the book, Layer of Protection Analysis by Simplified Process Risk Assessment by CCPS. Layer of Protection Analysis, Simplified Process Risk Assessment by CCPS. So please go to the table now. फुल स्क्रीन कैसे होगा आपका होगा या मेरा होगा? ठीक है ना? So please go through the table now. How she is opening the table. That table we can refer for the RRF or PFD.
This is the chapter.
This is a chapter for identifying IPL, independent protection layers. Now please go through the table. There are IPL rules that we will discuss in detail in the 40-hour session. Now see the table. This is the one of the table. I think that's a table 6.3. That is the first table. Example of passive IPL. It's a passive IPL. So in case of dike, PF will reduce the frequency of large consequence, widespread spill of tank overfill, rupture spill. So PFD in this case is 1 to 10 raised to minus 2 to 10 raised to minus 3. So we can consider 10 raised to minus 2. So it's a two layer of, we can say controller IPL, two layer of IPL that we can consider here. Okay. Yeah, Ayush will maximize because it's we are sharing the book, so there is a difficulty in maximizing the screen. But definitely, please go to next table. It's a passive, basically passive layer. Please go to some active layer table. So passive layer means dike is a passive, doesn't act but will work as a safeguard or control. Now, example of active IPL. So relief wall is an example of active IPL. So you can see the table 6.4 example of active IPLs. First is relief valve, prevent system exceeding specified overpressure. Effectiveness of this device is sensitive to service and experience. So service means it should be clean service. There should not be any containment. So PFD range from 1 to 5, 10 raised to minus 1 to 10 raised to minus 5. So we can say RRF 10 to 10 raised to 5. So basically, PFV used in this book is 10 raised to minus 2. So normally we should refer 10 raised to minus 2, but subject to the chemical is clean. There is no containment, no contamination. If there is a contamination, so there is a probability that pop-up will not possible at the time of expected or at time of demanded. So in that case, normally what we do, we keep rupture disk before the PSV. So normally rupture disk pressure, set pressure should be higher than the PSV, slight higher. So in any case, whenever there is a over pressure, so PSV will pop up immediately. So this is the basic consideration. Similarly, rupture disk also. If we take rupture disk and relief wall in line, so that we consider as a one safeguard, one control, and of course PFD can be 10 raised to 2. So two layers, we can consider two layers. So similarly, basic process control like a shutdown system. So in that case, PFD you see 10 raised to minus 1. That is RRF is 10. That is one layer of say protection. So these there are different tables 6.34. You can refer these tables and you can list out the PFD of each and every component. Right? Seal 1, seal 2, seal 3. So please go back. Please go back. So again, coming back to this first deviation, I think it's we have seen that after the addition of three available safeguard, risk mitigated risk is tolerable. So we need not to further go beyond this. So now I think it's already 3:45. So I think with this we are ending this session, and definitely we will coming up with more sessions every month, one plus 10 weeks detailed Hazop leader 40 hours program, and we are coming up with the postgraduate diploma in process safety management. Affiliation process is going on. If process affiliation will be completed, so this will be chargeable, or otherwise this will be a free program. uh, we may have other programs also based on the availability of different faculties. So definitely we will do it. Your motivation is definitely continuously required to us. Please be in the community, so you will get the update. Subscribe our YouTube channel, so you will get the update. You can follow us on the LinkedIn also, so you will get the update. And of course, thank you for your continuous this motivation clappings. Thank you very much. And definitely we will share the all the question answer through the video in the YouTube. Thank you very much for your patience during the interruptions also. Thank you for wonderful supports. Thank you very much. Hope to join you soon. I will share all the whole year program within a 2 to 3 weeks. You can join to the different form and you will be updated. And we have a lot of learning from this session by our team. So we'll share in advance all the links for the webinars also, so you can just register yourself, so you will be reminded by the mail also. And your the suggestions are welcome in our community group, so please continue to suggest us, so we will try to implement your suggestions. Thank you very much. You will now next step is that you will share the name of the list in the group, so please confirm your name. Based on name, we will prepare your certificate for participation, so you will receive individually the certificate also. Thank you. Thank you very much. We will share this presentation also in the WhatsApp community, and on request on the mail also we'll share this presentation. Thank you very much. Thanks a lot. Have a nice day. Have a nice future. Have a nice year 2026. Thank you.